or did you go to a party, or did you hang out with friends? I'd like to know. But myself, I went downtown and with some friends, and we learned about cybersecurity stuff. Pretty nerdy, I know, but it was absolutely packed in downtown, and it was. I thought that people might not be going out because it was a weekday, but it turns out that's not the case. All right, so okay, so user DG says went trick or treating with their friends. That's great. User D says sore. I'm not too sure why sore, but well, I hope you feel better soon. All right, so let's take a look at where our live stream is. Okay, so I've got the link for the live stream. Let's see, copy link. And if you want to catch this on YouTube, you can do so over here. We're going to be starting our lesson now. And like I said, if there are any concepts that you don't understand while I'm going through them, please don't hesitate to type in the chat and let us know that you don't understand, or if you're falling behind, or if you get some sort of weird errors, because we don't want anybody to be left behind in the class. Okay, so, all right, here we go. This is HackerFrogs After School Python Programming Basics, Part 6. And it's hard to believe we've already covered 6 of these sessions. It's been going by pretty fast. This workshop is the 6th class for Intro to Python Programming. And during our last workshop, we learned about a few programming concepts through Python, including the following. So we talked about programming loops. Loops are tools that programmers use to run the same instructions multiple times. Loops can either run a preset number of times before terminating, or iterate through all items in a list or string, in the case of for loops, or run continuously until a predetermined trigger state is achieved, in the case of while loops. So in this workshop, we're going to be covering a pretty important topic as far as programming in Python is concerned. We're going to be talking about functions. Functions. So the print statement here is an example of a function we've been using all this time in Python. Here we see print is a built-in Python in function. And programming functions are defined instructions that can be used multiple times in the same code. So basically, you can think of functions as kind of a mini program inside of a program. So every time we run a function, we're going to execute all the code inside of that function. If a specific set of instructions needs to be run multiple times in the same code, it is more efficient to create a function out of those instructions rather than input the same instructions again. So coding is all about being efficient with your time and all of your space and stuff. So we like to make functions if we're going to be running the same instructions again and again. In fact, we've been making use of the most common Python function this whole time, the print function. So print is a function. You know it's a function because when you use the print function, you use the word print, the name of the function, along with a pair of parentheses. So this is how you can recognize a function inside of Python. All right, so we've got a user on Twitch, Kamara J22. Hello, how are you? Doing just fine, thanks. We're just running a little Python instructional workshop over here. So any arguments that the function requires to execute properly, if any, are provided inside the parentheses when calling, that is, running the function. So when we're talking about functions, you'll often hear the term to run the function, to execute the function, or to call the function. All of these mean the same thing, but we just use different words sometimes. But usually people will say when you run a function, they'll say you're calling some function. I'm going to call the print function. I'm going to call the type function, or we're going to call some other function. So when we create a function, we have to use a certain set of keywords. So to create a function, we're going to start with the def keyword here, and then the name of the function, and then a pair of parentheses with any arguments required inside of the parentheses, then a colon. So inside of Python, defining a function is known as a code block, and code blocks always require there to be an indent after the first line over here. So since a function is a code block, on the next line we have to indent 4 spaces, then input the function's instructions. If the instructions span multiple lines, each line must be indented. Any argument variables should be included in the instructions. Okay, so let's create a simple function. So first of all, we need to access the online Python website, and you can access it over here. Remember that when you load up the website initially, there's going to be some code there. So what you need to do is you need to highlight all the code that's already there and delete it. Okay. So what we need to do is we need to use the def keyword and then space and then the name of the function. So I'm just going to call this function greetings, and of course we need to include a pair of parentheses and a colon over here at the end of the line. So greetings, and we're going to include one parameter in here, and the parameter is going to be name. So what this greetings function is going to do, it's just going to print with the f string, hello, and then in the curly brackets, name. How are you? Okay, so just like this, it's not super complicated. So this is just defining what the function does. This actually doesn't do anything. So if we just put this in the code and then we run this code, we'll notice that nothing happens. Nothing happens, and then it says process exited, return code 0. So the reason why is because defining a function doesn't actually run the function. In order to run the function, we have to... Can anybody guess what we would do to run the function? If you can guess what the command would be to run the function, please type in the chat, and if you do, I'll tell you if you're right or wrong. So it's kind of like running the print function. When you use the print function, you give the name of the function and then the pair of parentheses and whatever we need inside the parentheses. So can you guess at how you would run this greetings function over here? Okay, so the way you would run the greetings function here is you would type the name of the function, greetings, and then a pair of parentheses, and anything you need inside the parentheses, you provide it in here. So in this case, we need a name. So in this case, a name is going to be some sort of string. So we're going to include the string that we want for the greetings in here. So I'm going to use HackerFrogs, because we are HackerFrogs. All right, so we're going to run this, and it says, hello HackerFrogs, how are you? Okay, so everybody, I want you to give this a go. Just try creating your function over here. Remember, it's def space greetings, and then inside the parenthesis, the word name, and then the colon. So after the colon, when you hit enter, it should indent for you, and we just want this print statement over here. Inside the print statement, inside the f string over here, and remember the f in front of the double quotes. Hello, name, and name is in the curly braces over here. So after this, on another line, you're going to run the function greetings, and inside the parentheses, inside the double quotes, whatever name you want to do for the greetings. Okay? So try running this. If you're able to get this to run and it says, hello name, how are you? then type in the chat, I ran my first function. Smiley face. Okay, so user DJ ran the first function. Great to see, great to see. Okay. If you're getting some sort of error message, please let us know what error message you're getting, and we'll try to figure out what's going wrong with your code, okay? All right, let's move on. Once again, if you're having any sort of trouble writing the code, then please let us know what kind of problem you're having. All right, so we wrote a similar function over here. We've got def, the keyword, and then my greeting, name, colon, and then print it with an f string, greetings, name, and then we call the function over here. So here our example function is defined, and then the function is called with the corresponding output shown thereafter. So defining the function by itself doesn't run the function. We have to explicitly run the function after the function is defined before we run our function. So one thing I'm going to point out is that this might seem very obvious, but if we put our function call, so I'm going to cut and paste. If we put our function call before we define our function, this isn't going to work, because Python is going to run all the instructions in your code in order, and if you put the function call at the beginning before the function is defined, it's going to give you an error. So let's just try running this. It's going to say line 1, and it says name greetings is not defined. So this is because we didn't define the function before we tried to run the function. Okay. So the next thing we're going to talk about is the return statement. So inside of functions, you're going to see this return instruction very often. So we've got a function over here. This is called sales tax calc with an amount. So what this function does is it's basically going to add some amount of tax to a number. So the first thing we do inside of the function here is that we're going to set a variable called sales tax, and it's going to be equal to 1.15. So 1.15 is basically what we're going to multiply by to get the sales tax, and in this case it's 15%. And the final instruction here is to return the amount times the sales tax. So whatever number is set for the amount, that number is going to be multiplied by the sales tax, 1.15. So afterwards here, we're going to run the function, call the function with sales tax calc with the number 55. But the problem is that the return function doesn't print anything. So let's make this really quick. So inside of our sales tax calc, and we're going to put the variable called amount. So we're going to do, let's call this tax rate or tax percentage. And we're going to do 1.15, 15%. And we're going to return tax percentage times. So this is the multiply symbol inside of Python. And we're going to multiply that by the amount. So if we do sales tax calc with, let's say, 100. So what is the expected amount that's going to come back if we are multiplying by 1.15? So we're just doing 15%. So the amount that we should get back is If you know, put it in put it in the chat. Okay. So here's what happens if we run this code. So when we run the code, oh, wait, invalid syntax? Hold on. Sales tax calc amount, and then this. Wait, why is this invalid syntax? This is... Oh, no. I needed to put the def keyword. See, this is why it's important to pay attention. Okay, so sales tax, yeah, right. So I forgot to put the def keyword, so the Python didn't know that I was trying to create a function. So that's why it didn't go through. Okay, so let's run this again, and you're going to notice that nothing happens. So the reason that nothing appears, although we ran our sales tax calc function at the bottom of the code, is because this return function over here, this return keyword over here, doesn't actually print anything. So if you want your function to actually print something, you have to put the print keyword over here. So return doesn't print anything. So we have to explicitly print in order to get something to print inside of our function. So if we wrap this entire equation over here with print, then it's going to print something out. So if we run this, oh, right. Okay. Sorry, you're not supposed to use return with print. So what you want to do is you want to print this. You want to print the result of this function call. Okay. So let's run this. Okay, for some reason this doesn't round up. It doesn't actually give us 115, which would be the expected result. It gives us 114.99999. But that's interesting. All right, let's continue. So the point here is that the return keyword is an instruction that can be used in functions. When used, return is going to store the value specified, but it doesn't print out to the console. So the return portion of the function is useful for passing values to other parts of the program, but won't output to the console unless we use the print function with it. So this is what I just what I demonstrated. So we needed to wrap the function call with the print function here, and that's how we're able to get this thing to print. Okay, so the next thing we're going to talk about is setting variables inside of functions. So here we've got our name variable. It's equal to John. So this is a name. And then we're going to create a function called name set, new name. So basically what this function is going to do is it's going to set the name variable to the new name. So it's going to change it from John to something else. And then it's going to print that name. Okay, so if we run the name set function with the name Betty, and then we print out the name after the function is finished running, then the name is going to be set back to its default setting, which was John. So we see here that by default, if a function uses a variable which exists outside of the function, then any modification to the value of that variable will revert after the function finishes execution. So this is going to print out two names. What are the two names that are, when this runs, what name is going to be, when the name set function is run, what name prints out? And when the print name function runs, what name is going to be printed out? So I think we've got this in our, I think we have this particular piece of code in our GitHub. So let me go get it. This is session 6. No, this one isn't. Okay. All right, so let's demonstrate over here. So we've got our name, and our name is, so can somebody give us a default name? I'll put the default name in there afterwards. And can somebody give us a name? Oh, okay, so we've got Adam. All right, that's our default name, and we're going to do def name set, and we're going to call the variable new name. Okay, and all we do is we name equals new name, and then print name. Okay. Can somebody give us another name that we're going to run the new name, the name set function with? So one more. Let's see. So we've got some bits coming in. VM Smith has cheered 100 bits. Thank you very much for the bits, VM Smith. Okay, we've got another suggestion. It is the name Heidi. So let's do name set with the name Heidi. And then we're going to print the name variable over here. Okay, so here we've got our name, it's Adam. So, and then we define the name set function. When we run the name set function with the name Heidi, then it's going to print out Heidi. But then, the next time on line 8, when we print out the name again, we're going to see that the name has reset and it is the name Adam. So let's run this. Okay, so first it prints out Heidi and then it prints out Adam. Okay, so that is as expected. All right, so this is all to illustrate that anytime a function uses a variable that already exists in the code, after the function finishes running, that variable is going to reset back to its previous value. So in fact, any variables defined inside of functions are not accessible by the rest of the code. So the above code results in an error, name pynum is not defined. So we've got a little function here. It's called pynumber. So pynumber is set to the value 3.14. So this is the value of pi, and then it's going to return. If we run this pynumber function that basically creates this variable, it's when the function's running, then this variable pynumber exists. But if we try to access the pynumber variable afterwards, we can't access it because it only exists inside the function. So that is to say, variables that are created inside of functions can't be used by the rest of the program. Okay, so the next thing we're going to talk about is functions with parameters, and a lot of functions have parameters. You basically need to supply some sort of information when you run the function. So function can be written with parameters which are used inside the function's code block. So if you create a function with some parameters, and in this case it's A and B, you should include the name of those parameters, which become variables inside of your function. So let's create this one real quick. So I'm just going to grab this code. Okay, so what's going on here? So we're creating a function called add2numbers, and it has two parameters that we provide when we do the function call. It's A and B. So inside of the function, all that happens is that it's going to add the values of A and B, and it's going to store them with the return keyword over here. And then afterwards, we create a variable called x, and this variable called x is the result of add two numbers with the parameters 1 and 2. So when we print the variable x over here, what do you think is going to appear? It's going to be a number, but what number do you think is going to appear here? If you know, type it in chat. And it's okay to be wrong, because this is how we learn. So if we're wrong, and if we're wrong, it doesn't matter. It's just a guess, right? All right. So somebody, user DJ, guessed that it might be 3. So when we run the code here, the number 3 appears because the variable x is the add two numbers function run with the parameters 1 and 2. And because add two numbers is going to add the two numbers, then the result is 3. Okay. So the next thing we're going to talk about, so we talked about parameters, and a lot of functions have parameters. You have to provide the parameters when you run the function. But we also have functions with default parameters. So functions can be written with default parameters, which are substituted in if the function is called without specifying that parameter. So we've got some code over here. It's called greet user. So the greet user function here has a first name parameter and a last name parameter, and we set the defaults by using the equal sign inside of the function definition. So the first name is going to be John by default, and the last name is going to be Doe by default. And all this function does is it's going to print with the f string, hello, first name, last name, exclamation point. So we're gonna play around with this a little bit. So let's on this GitHub page, and I'll provide the GitHub page in the chat. What I want you to do is I want you to scroll down a little bit and go down to the code snippet 1 portion of the page. So code snippet 1, we've got this code that we were talking about on the slide, and there's this button over here that you can click on that's going to copy the code. So just click on the button to copy the code, and then go over to Online Python and delete everything that's already there, and then paste in the code that you just copied. Okay, so before we run this, what do you think is going to print if we do line 4? On line 4, we run greet user, last name equals Smith. What name is going to print out? So if you have a guess, then please type it in the chat. Greet user with last name equals Smith. So we've got the default John for first name and the default Doe for last name. And it prints out hello, first name, last name. So what name is going to appear if we run line number 4? Greet user, last name equals Smith. Okay, so user LD says not Smith. User D says John Smith. Okay, so let's try running this. So we're going to run this code, and it says hello John Smith. So because we specified that the last name is going to be Smith, then the default is not used. Otherwise, it would have used John Doe. If we run this without any parameters, so without any parameters, then it's going to use the default parameters where first name is John and last name is Doe. Okay? So when we run this, by default, then the first name is going to be filled in with John, and the last name is going to be filled in with Doe. So if we run it without any parameters specified, it uses the defaults, and it prints out hello John Doe. But if we run this with first, so we can run it like this. We can just provide two strings, and if I do the shy hat, then it's going to fill in, the is going to be for first name and shy hat is going to be last name. So in this case, we don't need to specify first name and last name. It's going to do it for us because the first position is going to be first name and the second position is going to be last name. So if we do it like this, then it's going to run and give us hello the shy hat. So everybody, why don't you give this a try? And I want you to use your own name when you do the function call. And well, you don't need to use your name. You can use any name you want. But if you're able to get this to run using your name, and your name might be, it could be Batman, then it's going to say hello Batman, just like this. So if you can get it to run with the names that you define over here, then please type in the chat, I'm not using default parameters. Smiley face. Okay, so LD is not using default parameters. Good to see. Great to see. All right. So once again, if there's anything you don't quite understand about this little section over here, then please let us know and we'll try to answer your questions as best we can. And remember, if we put in bat, but we leave out the second parameter, then the second parameter is going to be filled in automatically with the default. So if we do this, what name is going to be printed out? So bat is going to fill out the first name over here, and the default is going to be filled in by the default, which is Doe. So it's going to say hello bat Doe. So we run this, hello bat Doe, hello bat Doe. All right, let's move on. That's user LD says that's a fire name. Well, maybe you can use that in the future. Okay. So that's default parameters. We talked about functions with parameters. And let's move on to our little exercise. User D says lol, and that's very, oh wow, we see someone with the name BatDoe in the Zoom call. That's great. Okay, let's move on to the exercise over at Learn Python. So learnpython.com, I think. Oh wait, this should be learnpython.org. Remember, everybody, that .com and .org are not the same thing. And they're going to take you to different websites. Okay, so let's go to our functions page. So everybody, please access the page over at this link. Oh, I didn't notice on Twitch. On Twitch, VM Smith has been guessing at what's going to be appearing in the function calls. Thank you very much for the bits, VM Smith, and I very much appreciate that, and I appreciate you participating in the class today. Okay, so if you see any ads, unfortunately, there are ads on this website, but I guess that's why this website is free. So just let's take a look here. So basically, this page is going to be talking about a lot of the stuff that we've been talking about today. And it says here, what are functions? Functions are a convenient way to divide your code into useful blocks, allowing us to order our code, make it readable, reuse it, and save time. So over here, it says, how do you write functions in Python? So basically, this is a code block. And so if we wanted to create a function over here, we would define it with the def keyword, and then we have to indent each one of these code blocks over here. You have to indent one time, and if there are any other code blocks inside of the code block, you can have code blocks inside of code blocks and inside of code blocks. You have to indent an extra layer each time you create a new code block inside a code block. I just said the word code block a lot. Okay. So we're going to move on. Over here, in the second window, it says it's going to create this my function over here. And all this is going to do is it's going to print hello from my function. But if we click the run button over here, nothing happens. So why does nothing happen when we click on this run button? This code is running, but nothing prints out. Can you tell me why nothing's printing out here? So the reason nothing prints out here is because the function wasn't called. So when we run a function, we usually call it calling a function or executing a function. So the function's not executed in this case. So we need to execute it by giving the name of the function along with a pair of parentheses. So we know we don't have to provide anything when we run the function because when we create the function, there's nothing inside the parentheses. So when we give this instruction here, then it's going to actually run the function. So click on run and it says hello from my function. Awesome. Okay. So the next little box down here says functions may also receive arguments, which is variables passed from the caller to the function. For example, we've got this function over here. It says it's define my function with arguments, and we've got username and greeting. So what does this function do? We need to provide a username and greeting when we call it, and it's going to print hello string from my function, I wish you S. So these are both strings over here. And this is a slightly different way of using variables inside of strings than we're used to. But this is the way you do it when you use C-style strings. So we didn't talk about this, but basically the strings in here are replaced with username and greeting in this case. So if we run this function, my function with underscore args, and we provide two strings, and for username we're going to do batdo, and the greeting is going to be I wish you a happy Halloween, even though Halloween is over. Okay. So what's going to print out? Can anybody guess what's going to print out? It's going to be a sentence. And it has something to do with this. What do you think is going to print out? Okay, so if you guessed hello batdo from my function, I wish you a happy Halloween, then you're correct. Okay, so another thing that I didn't bring up is that you can actually specify what you want as your username and greeting by doing this. So username equals Batdo and greeting equals a happy Halloween. But you don't need to do this. You can just do it by the position. So username first position, greeting second position. Okay. So next, we see functions may return a value to the caller using the keyword return. For example, sum two numbers AB, return AB. So in this case, sum two numbers AB, we can replace it with anything. So we could do 1337, and we can do a really big number. And when we run this, this is actually going to be a bit inaccurate. It's going to say out this number over here, but in reality, Python programs aren't going to show you this. So what you need to do if you actually want to print this is you need to wrap everything in print, because the return keyword doesn't print anything. So you notice that this is not out, it's just the number. Okay. So does anybody know, how do you call functions in Python? So everybody, let's just assume we want to call my function inside the code. How would you type that out in the code to call the function, to run the function? So type what you think it might be in the chat if you want to run the my_function function. In the meantime, I'm just going to have a little sip of coffee. I'll be just a moment. So if you want to run this function, VMsmith01 asks, where should we type our answers? You type the answers in the chat. So just type the answers in the chat box, and hopefully I respond. So what you want to do to run my function is to just use this code over here. Actually, it's this code right here. My function with the parentheses. So we see that we have our previous functions over here. User D says, Batdo's profile picture is amazing. So Batdo, you're getting some compliments. I hope you appreciate it. Okay, so that is a great looking profile picture, I must say. Just a little inside joke for us Zoom call people. Okay, so we've got our exercise. So I don't like this exercise, so I'm going to skip the exercise, and instead we're going to be doing something different. So we're going to be doing a picoctf exercise as our final exercise for the day. So picoctf, please log into your picoctf website. So just go over to picoctf, play. Just in case you don't have the link, let me provide it to everybody in chat. It is over here. But before we do the picoctf exercise, let's do a little quiz. So everybody, please type in the answer you think is the correct answer. If you think the correct answer is A, B, or C, please type that letter in the chat. So we've got our function over here. What will print to the console? We've got add numbers, return AB, add the number 2 and 3. Is A going to print? Is B going to print? Or is C going to print? So is it going to be the number 5, there's a syntax error in the code, or nothing will be printed to the console. Okay, so we've got some guesses. We've got some guesses A or and B. The answer is actually C. Nothing will be printed to the console. So can you identify why nothing's going to be printed to the console? It's because there's no print statement in here. You need a print statement for something to be printed to the console. So return doesn't do it. You need to use the print statement explicitly to print something. Okay, so question 2, my number equals 7, and then we've got number set with the number. It's going to turn the my number variable into the number. We run number set with the number 14, and then we print my number. So we run this function that sets the variable to 14, and then we print my number. Is the number 7 going to print, or is it the number 14 that's going to print? Is it going to be option A or option B? What will print to the console? Okay, so if your answer is the number 7, then you're correct. So remember, we mentioned earlier that any variables that are set inside of functions are going to have that variable reset after the function is done running. So if we printed the number set function over here, then it would print at 14. But after this function finishes running, then my number is going to reset back to its original value, which is 7. But that's just something we need to remember when we're dealing with functions. Okay, so the last question is this. In Python, what does it mean to call a function? Choose 2 of the following 4 options. A, to define a function and its parameters. B, to execute the code within a function. C, to communicate with the function by phone. Or D, to invoke a function by using its name followed by parentheses. So we need 2 of these letters. Which 2 letters define what it means to call a function? A, B, C, or D? Well, you need two of the letters. Okay, so user batdo says B, D, and B. So these are both correct. Okay, so those are the 2 answers that we're looking for. So calling a function is executing the code within a function, or to invoke a function by using its name followed by parentheses. VMSmith01 also has it correct. Okay, great to see. So let's quickly do the PicoCTF challenge. And the PicoCTF challenge we're doing today, actually before we do the PicoCTF challenge, we need to log into our web shell. So when you're logged into PicoCTF, click on Practice, then scroll down a little bit, and then click on the web shell over here. So there's a button called Web Shell. It's going to be on your right-hand side, and it's going to be this gray button. Just click on that, and then the web shell is going to start up. But sometimes the server does not respond. You just need to click on Reset. Everybody, if you are also having trouble connecting to the web shell, please let us know in the chat, because there might be something going on with PicoCTF. Sometimes they do maintenance on their servers, and we can't use the service when maintenance is going on. Let's try that again. And remember, when you're having trouble with the web page, you can always reload the page and see if that fixes it. So I'm going to try reloading this page. Okay, so just click on the web shell. And if it doesn't respond after a few seconds, you can try reloading it. Starting web shell session, is it going? Is it happening? I'm sorry to everybody who has to who has to wait for me because I'm having technical difficulties. Okay, so close that, click on Web Shell again, click on Reload Web Shell Terminal. Click on Web Shell again, reload Web Shell Terminal. Okay, it's working now. All right, so after this is done initializing, click on this button over here, which is called Pop Out Web Shell Terminal, and that should put the web shell in its own browser tab over here. This is what we want. Okay, so if you're ready to solve the challenge because your web shell is up, please type in the chat, web shell up, smiley face. Okay, we've got some web shells up, great to see. Okay, so the challenge we're doing today is called Inspect HTML. You can find it over at this link, which I'm going to put in the chat. Okay, so just go over to the challenge page. And this is the Inspect HTML challenge. It says, can you get the flag? Additional details will be available after launching your challenge instance. So what you need to do to start the challenge is you need to click on this button over here called Launch Instance. So this is going to start the start of the website that we need to access to get the flag. So after you click on the blue button over here, and it actually responds. So PicoCTF doesn't seem to be super responsive for me today, but sometimes you're going to get an error. You just need to keep on trying. And if it keeps on being non-responsive, then you just need to keep on trying. Okay, so the instance started up, and you'll know because the button over here turns from blue to red. And now we've got a website link over here. So this is going to take us to the website that we need to access to get the flag, but we're not actually going to use our web browser to access the website. We're going to use Python. So over in our GitHub, so the GitHub is over here. What I want you to do hold on. So I'll give you the link to the GitHub over here. What I want you to do is I want you to go over to this end of session exercise section over here, and this is the code we're going to use to solve the challenge. And what I want you to do is under the end of section exercise with this code over here, you want to click on this button, which is going to copy the code. So just click on the button. It's going to be on the right hand side. It's two boxes. Click on it. It's going to say copied. Then go over to your web shell, and it might have disconnected you. You just need to hit enter to reconnect. Lots of connectivity issues for me today. Okay, so I'm going to reload this page. Let me try putting this in another tab. I'm just going to spend a little bit of time reopening my web shell. It seems to have gone weird. Let's see. Which snippet did we use? We didn't use the snippet. We used the end of session exercise code. So over on the GitHub, end of session exercise. So it's the first line is import OS. Just copy that, and then in your web shell, you're going to give the nano command, and it's nano space webpage fetch.py. So we're going to create a Python script called webpage_fetch. So just type in nano space webpage_fetch.py, hit enter, and that's going to, oh, this is the wrong thing. So let's call it something different. How about webpage_get? So we're going to do nano webpage_get.py, which creates a script called webpage_get. Okay, and then we're going to paste in the code. After we enter the editor, we're going to right-click and select paste, and that's going to paste in our code. So this script over here, the first thing that happens is we're going to import OS, which lets us use operating system, which is Linux commands. And the first thing is there's going to be a URL variable, which is equal to user input. And the user input is which web page do you want to read? And then the second line over here is going to be a curl command. Curl is a Linux program that lets you download web pages. And what this is going to be set to is an f string, which is curl with the URL, which is this variable that we defined in the previous line. And then we create a little function. So this function is called read web page with the curl command. So it's going to use the curl command as part of its parameter. And what this is going to do is it's going to print out with the OS function, with the OS module over here, popen. So open with this command, the curl command in the read mode over here. And then we're going to, the last thing we're going to do in the code is we're going to call the function read web page with the curl command. Okay. So after we've pasted in the code and we understand what the code does, which is to use this curl command and then print it out for us, we're going to save this. So Control X to save, press Y to save, and press enter to what is the word? To verify. Okay. Confirm rather. Okay. So all we need to do to finish this challenge is we're going to use Python with webpage_get. So this is going to run the Python code inside this file over here that we just saved, webpage_get. We hit enter. It asks us which web page do you want to read. So we go over to our challenge page, and there's this link over here for website. All we need to do is right-click on the word website, copy the link, then go over to the web shell. In the web shell, we can paste in the link and then hit enter. And so what this does is it runs a Linux curl command, and then it prints out the feedback, the output. So this is the web page, and inside the web page over here, there's the picoctf flag inside this comment, this HTTP comment. So all we need to do to finish the challenge is copy the flag, then go over to go back to the challenge description page, and in the flag submission field, paste in the flag, and then click on Submit Flag. And it's going to give me connection issues, because why would it not give me connection issues? Okay, so if for some reason it doesn't let you submit the flag the first time, then keep on trying after it times out, and then click on Submit Flag again. And if it doesn't work a second time, then it might work the third time. But if you manage to finish the challenge, please type in the chat, I read that web page. Smiley face. Okay, so it finally accepts my my input. Great. All right. User VM Smith says, I missed a step before attempting to execute the link. Okay. Let me demonstrate one more time. So the step right before, whoops, this isn't what I want. I want this. The step right before is we need to create the file. So to create the file, we need to go to the code over here. We need to end of session exercise. This code over here, there's a box. We need to click on the box to copy the code. Then go over back to our web shell. We're going to, let me go into a temporary directory. We need to create a page called webpage_get. So it's nano space webpage_get .py for Python. So create this file instead of nano. Right click, paste in the code, and then after you've pasted in the code, you can save it. Control X to save. Save modified buffer Y for yes. Confirm with enter. And then we can run the script by doing the Python command, Python space webpage_get.py. It's going to ask us which web page do you want to read. Go back to the challenge, and there should be the link. Copy the link. Let me start this up. Copy the link. Go over to the link, right-click, copy link. Then go back to your web shell. Which web page do you want to read? You can right-click and paste in the web page. This address, hit enter, and that's going to use Linux to download and read the web page file. In the web page file, there's the flag over here. All you need to do is highlight it, copy it, and then submit it. Okay. All right. So everybody, that's the end of today's session. Let me just do the summary really quick. So functions are defined blocks of code that can be executed multiple times in the same program. Executing a function is usually referred to as calling a function or a function call. What's next? In the next HackerFrogs After School Programming Workshop, we'll conclude our intro to, well, we're not going to conclude. We've got a couple more left. But in the next workshop, we're going to be covering classes and objects as well as dictionaries. So that's going to be on Monday. So Monday, that's going to be November 4th, I think. But everybody, so to everybody on the live stream, we're going to be closing out the class on Zoom. And I'll be back in a couple of minutes, and we're going to be doing some hacking exercises afterwards. But just in a couple of minutes, hold on, and we'll be back in a couple of minutes. Okay, everybody, we're back, and we got a request from one of the Zoom students. They were having some troubles with their PicoCTF challenge. So I'm going to demonstrate one more time. So what I want you to do is just go over to in your web shell. Just make sure that your web shell is up and running, and I want you to, let's see, let me get rid of this. So type nano space web page underscore get, and just to make sure that we're starting fresh, we're going to do web page underscore get2.py. So just do nano space web page underscore get2.py, hit enter. And then you're going to be in the Nano editor. It should say webpage underscore get2.py. Go over to the GitHub page over here, and if you don't have it, it is this one. Okay. So after you copy the code, then go over to your web shell. In the web shell, right-click, paste, and then save. So this is where the user might have had a problem. So just do Control plus X. It's going to ask you if you want to save the modified buffer. Press Y for yes. And then the file name to write, hit enter. And that should save your file. If you do ls, you should see webpage underscore get2.py in your directory. So from there, just type in Python space and then the name of the file. Remember, you can just type out the first couple of letters of the file name and then hit tab to autocomplete the name of the file. So Python space webpage underscore get2.py, hit enter. It's going to ask which web page do you want to read. Go over to your challenge page, and then here you're going to highlight the link, right click, copy the link, then go back to your web shell. Which web page do you want to read? Right click, click paste. And that's going to input the name of the web page. Then hit enter. And then that's going to retrieve the web page. The web page over here, it's a bunch of stuff, but inside this output, you also see the flag. So you just need to highlight the flag, which is this over here. Make sure that you get everything up until the ending squiggly bracket. Right click, select copy, then go over to the challenge page. In the challenge page at the bottom, there's a flag submission field over here. Paste in the flag. You can use Control V to paste in, or you can right click and select paste. Either one will work. And then click on submit flag. Okay. All right. So User D has finished the challenge. Thank you very much for letting us know that you were having problems. If you're having problems, you need to let us know so we know to help you out. Okay. All right. So to all the students on Zoom, we will see you back on Monday. Have a great weekend, and we'll see you next time. Okay. All right. So I'm going to end out the Zoom call now. And okay, so to all the other HackerFrogs in here, we're going to be doing some free hacking exercises now. And free hacking means we're going to be working against some hacking challenges. So the hacking challenges that we've been doing for the last little while have been on the VulNyx website over here. And if you're looking for that, you can find it over at this link. And these are challenges where you have to run a virtual machine, a VM, on the same network as your attacking machine, and by attacking machine, we mean a virtual machine that you can use to do security testing, something like Kali Linux. So today we're going to be continuing on our journey with which machine was it? Let me see if I can get it. So I think we were looking at the hidden machine over here. Yeah, this one right here. So this is an easy level machine. So I found that easy level machines on this website are not so easy. You will see what I mean. So I'm going to try playing some music for everybody. And the music I've got for today is from the Mass Effect 2 game. So Mass Effect is one of my favorite video game series, and it's got some really great space-themed music. So I'm going to play that while we do our free hacking segment. So I'm going to start playing that, and let's see if I can hook it up to the stream. Just need to do a little bit of finagling. Okay, you should be able to hear it. If it is too loud, please let us know, and we'll try to adjust the volume as best we can. It is a little loud in my ears, so I'm going to turn it down a smidge. Okay. Alright, so the first thing we need to do is we need to start up the virtual machine on our same network. So what I'm going to do is start up the machine in VirtualBox. This is the hidden machine. I've got so many of these virtual machines on my list, but we're going to see VirtualBox is running over here, and in a few seconds it's going to finish booting up. So this is VulNyx hidden. We have an IP address that we need to hack against, and the IP address is 10.0.2.43. So let's remember to that IP address. Okay. So what we need to do is we need to start up some terminals, because we need to run a bunch of different programs to do security testing against this box. Okay. So the last time we took a look at this box, we did an Nmap scan to determine what services were available, and we found port 22 and port 80. So a lot of these challenges I find only have two ports open, a web port, which is port 80, and port 22, which is the SSH service. So another thing that we found was, when we did our UDP scans, was that there was the TFTP service open on the box, which means that we could do file upload and download. So I kind of when I did my scans against this box, I got a little bit tunnel visioned, and I just tried to find out what files we could download from the service. TFTP is special because you can't list out any files, and we need to do a little bit of brute forcing to figure out what files might be available on the system. So I did a couple of different brute force word lists to try to figure out what was on the box. We couldn't find anything. So I got some hints. I asked for a hint about this box, and they said that you can upload using TFTP as well. So, and I hit my head, because I knew this. I knew that you can upload using FTP and TFTP, these two services. And if you can get file upload on the system, then you could potentially get malicious code execution on the system as well. So what we're going to do is we're going to create a file. So I'm going to go into my temp directory and I'm going to create a file. I'm going to call this file, actually, we're going to do echo, and we're going to do the echo. The contents of the file are going to be, we have file upload, and I'm going to redirect that into a file called test.txt. Okay? Wait, that doesn't work. It doesn't work because we're using the wrong quotes. So sometimes you have to use single quotes, and sometimes you have to use double quotes inside of Bash, inside of Linux. And sometimes generally the stronger quotes are the single quotes, and that's going to let you interpret everything as a string inside of the single quotes. The other way is to do double quotes, and if you do double quotes, then you're able to pass certain arguments into the string when you use double quotes. I'm not completely sure about how it works, but if you use single quotes instead of double quotes, you're generally able to use any characters you want. Okay, so when we take a look at test.txt, it says we have file upload. We're going to try to upload this to the web server. So we're going to use the TFTP program at this IP address. And these are the commands we can use. We can connect, mode, put, get. So I've been trying to determine what we can get from the TFTP server, but we weren't able to get anything. So what we're going to try this time is going to try putting a file on the server and seeing if we could access it via the web. So we're going to do put space and then test.txt. So we're going to try to put our example file that we just created onto the web server. So it doesn't give us any output, but what we can do is we can go over to our web browser and we can try to access that page. So the page is HTTP 10.0.2.43, and we're going to access test.txt to see if we can access this file over here. And we receive this. We're able to access the file that we uploaded here. It says we have file upload, which means that we can potentially do malicious code execution. So we're going to do that to try to get a reverse shell on the system, and to do that we're going to use a PHP reverse shell that I like to use, which is located at pentestmonkey. PHP reverse shell, and we can find it over at GitHub. Okay, so over here we've got PHP reverse shell. I'm just going to click into it, and we're going to copy. Oh, we can copy the raw file. So we can copy this file, and this is PHP code that sends a connection to another server. So we're going to use that to get reverse shell access to the web server. So from here, I'm going to go to another tab, go to my temp directory. I'm going to create this file on my system, php reverse shell.php, and then I'm going to paste in all the code I just copied. So it's got a bunch of PHP code in here, but there are a couple of things that we need to adjust. So the things we need to adjust are over here. We've got the IP address of our attacking machine, and then the port that we're going to connect to. So my IP address for the attacking Kali machine is 10.02.22, and the port we're going to select is port 443. I like to use port 443 because it is a commonly allow listed port on web servers, and most web servers have an allow list, which only allow outgoing connections to certain ports. 443 is usually one of these ports because it's associated with HTTPS. But let's save this out now that our configuration is done, and then let's go back to our TFTP shell over here. We can upload the file using the put command. So it's put reverse shell. What is it called again? PHP reverse shell.php. PHP reverse shell.php. So we're going to upload this file, and then we're going to try accessing this file to get a reverse shell connection on the system. Okay, so we don't receive output, but we're pretty confident that the file has been uploaded. So let's go to another tab over here. This tab is going to be our reverse shell tab. So for reasons that we're going to go over later, I'm just going to run the bash command to change our console from ZSH, which is the regular one for Kali, over to the bash terminal. And then we're going to run netcat with a listener on port 443. So this is the listener that's going to catch a potential reverse shell from the victim system. Okay, so now we can go over to our web server, to our web browser rather, and then we can access that page from the web browser. And this is PHP reverse shell.php. Okay, so when we try to load this page, we'll see that it hangs. It basically doesn't go through. It's in the middle. So that's actually a good sign. It's a sign that whatever code is executing in that file is not resolved. So if we go over to our reverse shell listener, it's gotten a connection back. So it's gotten a connection back from the victim machine, which is this IP address. And what we can do here is we can do who am I. It tells us we are the www data user. So we're in. So what we need to do is we need to put on our scary hacker voice and say that we're in. I just have a voice changer that lets me do that. So let me put on my...
This is my scary hacker voice. I use this when I want to say scary hacker things like, we're in.
Okay, so I hope you found that amusing. I always found it amusing. And what we can do is we can, first of all, we've got a netcat shell. Netcat shells are not very good because they lack a lot of features that better stable shells have, such as command history and interactivity. So what we need to do is we need to go through a couple of steps to make our shell better and like a normal shell. So the first thing we're going to do is we're going to figure out which version of Python is running on the system. Sometimes it's Python, sometimes it's Python 3. So this is running Python 3, so I'm going to do a Python 3 command to upgrade my shell slightly. VMsmith has given us the what is this emote called again? It's the hype one, right? It's the HackerFrogs hype emote. Thank you very much for using it, VMsmith01. Okay, so the command we're going to use to upgrade our shell using Python is import pty for sudo terminal, pty.spawn, spawn a bin bash terminal, and this is going to let us upgrade our shell a little bit. So from here, we've got a prompt, and our shell is better, and we can actually interact with we can do interactive commands, but we still don't have total features, all the features. And what we can do from here is we can upgrade our shell again to a regular one by doing this. So we're going to do Control Z to get out of this shell and go back to our regular Kali terminal. And then we're going to run STTY-A to get some information about our terminal over here. So we've got 26 rows and 111 columns. We need this information to upgrade our shell. So after that, we're going to run STTY raw echo so that we can... I'm not completely sure what this step does. I'll do a little bit of research later, but basically I'm just playing the I believe button, the I believe game right now. So we run this command, and then we press the FG command to go back to our netcat shell. So from there, what we're going to do is we're going to... Oh gosh, let me look up a little guide. I don't remember all the steps. So you would search something like netcat shell upgrade. So upgrading simple shells to fully interactive TTYs. Okay, so the command is... Okay, so I just foregrounded my shell again, and then I need to reset. Actually, you don't need to reset. So I'm going to export shell equals bash. Okay. Export shell equals bash, and export term equals xterm 256 color, and then I'm going to do STTY rows. It's going to be 26 rows here, and columns 111. Okay, so I think that's all of the instructions we need to give. Okay, so we should have a fully functional shell now. So I should be able to do clear, I should be able to get my command history, and I should be able to use text editors like Nano. So nano test.txt. Okay, we're able to use Nano. So normally when you have a regular netcat shell, you're not able to do any of these things. As well, if I do Control X, I can actually get out of... This doesn't break my shell. So if you're using a regular netcat shell that's not upgraded, Control C is going to break your shell. Okay. So, okay, well, now that we spent a lot of time upgrading our shell, we can actually do some enumeration. So the first thing I like to do is I like to figure out if our current user has super user permissions by doing sudo-l, and we do. Okay, so it says user www-data may run the following commands on hidden. So as the Satan user, we can run with no password user bin dash. So I guess there's a user on the system named Satan. This would have been useful for Halloween because that's spooky. So if we take a look at the etc password file, this is going to tell us all of the users on the system. So the only regular user we see here is this Satan user, which has a home directory at /home/Satan. The only other user that has a login is the root user, which we want to become to compromise the system. So if we go over to user home, we see that Satan has a home directory here. But we also know that the dash binary can be used as the Satan user. So dash, I'm not sure what dash is, but I think we can figure out if we can abuse it by taking a look at the GTFO bins. The GTFO bins website. So GTFO bins is a collection of different privilege escalation techniques for different Linux binaries. And if you want to take a look at it, you can take a look at it over here. So what you can do is you can just go down here and we can search in here for whatever binary you want to look up. So I'm going to look up this dash binary. I don't know what it does, but we know we have sudo permissions on it, so I'm just going to click on this button, sudo. So it says, if the binary is allowed to run as superuser by sudo, it does not drop the elevated privileges and may be used to access the file system, escalate, or maintain privileged access. So I don't actually know what the dash binary does. So what I'm going to do is I'm going to ask ChatGPT for a summary. What is the Linux dash command? Oh, this is a shell. The dash command in Linux is a lightweight POSIX compliance shell. It stands for Debian Almquist shell, which is designed to be fast and minimalistic. So dash is basically another version of bash, or the sh shell. It's a different type of terminal. Okay? So very simply, if we're able to use this binary as the Satan user, we can just use sudo -user Satan, and then we run user bin dash, and this is going to open up a shell for us in the context of the Satan user. So it says sudo unable to resolve host hidden, no address associated with the host name. Okay, well, I mean, that's unfortunate, but who are we? We're Satan now. And are we able to get our... Oh, our shell is... Okay. So our shell is not upgraded anymore. Because we don't have access to our command history. But let's see if... So I think we can use Python to upgrade this shell as well. So we're going to Python C again, import pty.spawn bin bash. Okay. Okay, and now we have our command history back. Great. So we managed to downgrade to the dash shell to get access to the Satan user, and then we upgraded back up to a bash shell using the Python command. So let's see if Satan has any sudo permissions. So Satan has sudo permissions, and we're able to run the following commands. So with no password, we can run... We can run this program on this program? You know what? I need to ask ChatGPT exactly what this means. And I don't know either of these two programs. Just in case you were wondering. This is sudo l output. Please interpret it for me. Okay, so the sudo l output, let me close this out. Okay, close the sidebar, make the text bigger, make the text smaller. Okay, the sudo l output specifies the commands that the user Satan can use with sudo privileges on the host hidden. Here's what it means. User Satan, the permissions applied specifically to the user Satan. Okay. Host hidden, this is the machine most likely named hidden on which the sudo permissions apply. All means that Satan can execute the specified commands as any user and any group on the system. No password indicates that Satan does not need to enter a password when running with these commands with sudo. And this program and this program are the specific commands that Satan can run without a password. Okay. So, privilege escalation possibilities. Geany is a text editor with a graphical interface, which can be used to open files with elevated privileges. So Satan could potentially open sensitive system files such as etc shadow or etc sudoers and modify them. Or xauth. This command manages x11 authorization, which might not directly provide privilege escalation to be leveraged in certain situations involving graphical session manipulation. To exploit Geany for privilege escalation, Satan could open critical system files with it, possibly altering permissions or creating new users with root access. Okay, so let's look up what can be done with the GTFO bins. So we're going to go back and we're going to look up Geany. Okay, no matches. The other program was called xauth. Okay, so let's do a little bit of experimentation here. So we're going to do sudo Geany sudo unable to resolve the host hidden, no address associated with that username. Unable to init server could not connect, connection refused. Cannot open display. Okay, so Geany is looking to open up a graphical interface, but we don't have a graphical interface. So that's a problem. It also said that we were unable to resolve the host hidden. No address associated with that host name. So we can take a look at the etc host file to see what hosts are. Okay, so this host is known as this over here. So what we need to do is we need to see if we can modify the etc host file first of all. Let's see if there are loose permissions associated with this file. So we can only read. So we can't actually add to the etc host file over here. So that's unfortunate. But what we can do is we can take a look around some other parts of the file system. So let's move into our home directory. And in our home directory, we've got the following things. So config, profile, bash rc, bash logout. Let's move into the .config directory to see if there's anything here. Nope, nothing here. Okay, so what options do we have? We could try Googling this. So, okay, so Geany privilege escalation. Not working via sudo is a Geany bug. Running user code as root is an archetypal. Okay, let me take a look at this. Not working via sudo is a Guinea bug, not a feature or a bug in sudo. Okay. So the first problem is that Guinea is a graphical user interface program, and we don't have access to a graphical user interface. So as a reply, raising this bug, get a properly configured sudo. Even though I don't recommend using Guinea as root, I can run sudo Guinea on my Debian machine and it works flawlessly. As far as I can tell, whether or not I have other Guineas running, it probably uses root config Guinea. Okay. Okay. So let's try asking ChatGPT if it can solve any of our problems here. Sudo Guinea. Okay, ChatGPT, solve all of our problems. Help with this man. Please help with resolving these issues. Okay. These errors suggest two main issues. Host resolution. Sudo is unable to resolve the hostname hidden. Okay. Display issue. Guinea is trying to connect to an X11 display, but it's unable to open the graphical display. Let's tackle each issue. So the error message, sudo unable to resolve host, no address associated with this hostname, usually means that the hostname isn't mapped in /etc host. To fix this, open etc host in the text editor, and then add the hostname hidden. So we can't do this. We can't do this because we don't have access to the /etc host file. But let's see, resolving the X11 display issue. Since Guinea requires a graphical display, there are a few options depending on whether or not you are accessing the system locally or over SSH. So if you're running locally, we can start an X11 session. If you're on a local console without a desktop environment, try running startx. Then retry sudo Guinea once the graphical interface is active. If you're connected over SSH, you'll need to enable X11 forwarding to display it on your local machine. So in order to enable X11 forwarding, you have to connect with SSH using the -x or -y option. So SSH -x satan.hidden, okay, and set the display variable. Manually set the display variable start Guinea with sudo. This should open Guinea on your local display, assuming your local machine is X11 capable. So what if we have shell access to the system, but not over SSH? Okay, so steps for running Guinea without SSH. Check the display variable. First, confirm if the display environment variables is set. If it's not set, the system won't know where to render graphical applications. Echo display. Okay, let's try this. Echo display. No, nothing's there. If nothing outputs or an error, set it to 0. Set it to :0, which is often the default display for local X11 environments. Okay, so we can try setting this environment variable. Okay. Verify that X11 server is running. If you're working locally without a desktop environment, you may need to start an X11 session. Run this. This should bring up an X11 session on display 0. Now try launching Guinea with sudo. Run Guinea in headless mode if GUI is unnecessary. If you only need Guinea to edit a file with elevated privileges and don't require a graphical interface, you could try using a text-based editor that doesn't need X11. Sudo nano path to file. Install a virtual frame buffer. I don't know what any of these words mean. If you must use Guinea but don't have a display, you can install a virtual frame buffer like this, which emulates an X11 display in memory. Okay, so first of all, let's try to see if we can actually start up a graphical display. So start X. Let's try that. Start X not found. So, how can we start a graphical display if we have access to the XAuth binary? Okay, if you have access to XAuth, you can set up X11 forwarding manually by creating or updating an X11 authorization for my user. Whoops. Here's how to do it. Set up a display variable. Okay. Generate a new XAuth key. Use XAuth to generate a new X11 authentication token and add it to .x authority file for authorization. This command will create a new X11 authorization entry for display. Add authorization. If necessary, you can explicitly add authorization entry for the display :0. Okay. When we tried running the start X command, the system reported command not found. If start X is not installed, it likely means there is no graphical environment or X11 server installed on the system. You can still try to set up in a virtual X11 environment using XVFB, which is a lightweight virtual display server that can run without a physical display. Okay, so let's take a look and see if this is installed. XVFB. So this thing? How about just this thing? Nope. XVFB. Nope. Doesn't exist. Okay. I guess we need to improvise then. So if you do need to see the GUI, consider running. Alright, so I think we're going to need to put a pin in this, because what we need to do is we need to do our HackerFrogs class. So the HackerFrogs class for 5 o'clock Pacific Standard Time, 8 o'clock Eastern Standard Time is going to start soon. So we're going to put a pin in this and we're going to come back. So first of all, I'm going to turn off the music because we don't play music during our HackerFrogs classes. And the next thing we're going to do is we're going to grab the session notes for this session. If you're here for web app hacking, please type in the chat web app hacking with some smiley faces, just to know that you're here for that web app hacking. Okay, so this is session 1, and let me grab the presentation file for that. Web app hacking. It's web app hacking time. MSec, hello. Hey, nice to see you here. You're probably not going to learn very much when you watch today's class, but you're welcome to stick around if you like. So let me just grab. Okay, so these are the presentation files. All right, so everybody, we're going to do. Let's see. Let me download my PDFs. Okay, so everybody, we're starting our web app hacking course. It's going to go over 8 sessions, which is going to take about 3 weeks or so. But let us begin. So this is the HackerFrogs After School Web App Hacking Intro. So after this, we're going to start into our web app hacking course. But welcome to HackerFrogs After School. HackerFrogs After School is a cybersecurity program for learning beginner cybersecurity skills across a wide variety of subjects. This session is talking about the intro to web app hacking. But what is web app hacking? Web app hacking is the intentional abuse of systems and applications accessed via the internet by a user, which benefits that user in some way. This benefit can take the form of access to unauthorized data or systems, the deletion of data, denial of website services, or any number of other benefits. In order to learn web app hacking, we must learn about the internet, how websites work, and a good amount about the technologies and software found in that space. Most students know at least the basics of using a web browser and how to use websites. So we will build on those skills to establish a collection of techniques to explore and hack web applications found on the internet. Zohab Hassan, hello. Hack the planet. Hack the planet. Nice to see you. Nice to see you here. And we're just starting our web app hacking course over here on HackerFrogs. You're free to sit in on it if you're interested. But this is for students who want to learn the basics of web app hacking. So it is important to note that at no time during our study of web app hacking will we engage in testing or hacking of websites or internet spaces that A, we do not own, or B, are not intentionally set up as learning environments for web app hacking education. So what are CTFs? HackerFrogs After School classes prefer to incorporate CTF games into classes for a more interactive experience. But what are CTFs? Cybersecurity Capture the Flag, CTF games, are training exercises where the goal of the exercise is to capture the flag through use of cybersecurity skills. In this context, capture means to gain access to a file or other resource, and flag refers to a secret phrase or password. The CTF game we will be playing to learn basic web app hacking skills is called Natas, which is hosted on the Over-the-Wire CTF network. The Over-the-Wire network hosts several different CTF games. The Natas CTF game is made up of many levels of increasing difficulty, and the initial levels from 0 to 10 are going to cover the target web app hacking techniques for this course. So in the next workshop, in this session rather, we're going to begin our journey into web app exploitation with the Natas CTF game. So this is part 1. So this is the first workshop in our Intro to Web App Hacking course, and let's introduce the learning materials we'll be working through in the course. So Natas CTF, we were just talking about that. And in today's lesson, we're going to go over levels 0 to 3 in the Natas CTF game. So to learn about the Natas CTF rules, let's navigate to the following URL. So overthewire/wargame/Natas. So let me grab that Let me grab that. So it's Natus CTF over the wire. Okay. So if you want to take a look at the web page we're looking at here, you can do so from this link. And let's go over, it might be a bit too big. Okay, so Natus, the description here says, Natus teaches the basics of server-side web security. Each level of Natus consists of its own website located at http natusx.natus.labs.overthewire.org, where X is the level number. There is no SSH login. To access a level, enter the username for that level, for example, Natus0 for level 0, and its password. Each level has access to the password of the next level. So on each level, what we need to do to complete the level is to get the password for the next level. Your job is to somehow obtain the next password and level up. All passwords are stored in /etc/natus_webpass. For example, the password for natus5 is stored in the file /etc natus_webpass/natus5 and is readable by natus4 and natus5. Okay, so this last part over here basically tells us that if we're able to somehow access the underlying web server, and we will in a few different levels, then this is the file location where we're going to be able to find the passwords. But we're going to start at the very beginning, and the username is going to be Natus0, and the password is going to be Natus0 for this first level of the game. So if you want to access the very first level of Natus0, please navigate to this web link right here. And when you do so, it's going to ask you for some credentials. So you're going to have to provide a username and a password. Fortunately, we know that the username is Natus0 and the password is the same thing. So all you need to do to enter the level is to type in Natus0, and the password, you just need to type in the same thing, NATAS0. So after you've done that, just click on Sign In, and then you will access this web page here, and it says you can find the password for the next level on this page. If you're able to access this web page on your web browser, please type in the chat, I'm in, smiley face. If for some reason you're having trouble accessing the Natus0 webpage here, please let us know in the chat and we'll try to help you out with your problems. Okay, so let me see if I've got something in my presentation. Okay. Hold on. Okay, so on the web page here, it says that you can find the password for the next level on this page. So if anybody has done any kind of web app application security testing before, what can you do to get more information about this web page? Does anybody have a suggestion? If you do, type it in the chat and let us know. Okay, so what we're going to learn about in this first level is the concept of HTTP source code. So web browsers render out web pages based on the HTTP code that is provided by the web server. So every web browser allows us to view a web page's HTTP source code. So this over here is HTTP source code. And Notes by Nisha is here. Nice to see you here, Notes by Nisha. I think you've already done these sessions before, but nice to see you back. I'm glad to see you here. Okay, So this is HTTP source code, and what we can do is we can access the source code in a couple of different ways. So what we can do, first of all, is we can hit right click on with your mouse and then select View Page Source. But another way you can access the source code on the web page is to use a keyboard shortcut. And if you're using Google Chrome or Firefox, you can use the Control U keyboard shortcut. So you can just hit Control plus U at the same time, and it's going to give you the source code for the website. So we see here, this is an example of HTTP source. There's a lot of stuff in here. You don't necessarily need to know HTTP, the language, in order to understand what's going on here. You just need to know that this is code, and there is what is called a comment inside this code. So HTTP comments are a way that web developers are able to leave little comments inside their code. And we can see here that there's a comment over here that says the password for Natus1 is this over here. The reason why we can't see this normally on the web page is because there's a lot of this HTTP code that is not rendered onto the web page, because this isn't intended for regular people to see. And these comments are one of these things. These comments are only intended to be read by developers and other people looking at the code, and not by regular people. So we have the password for the next level. It's here. So this is what we would need to log into the next level. So all you need to do is to highlight the password over here and then copy it. So you can right click and copy, or you can use the keyboard shortcut Control C. So after you've done that, we can access the next level. So we're going to get out of here and we're going to access the next level. So to access the next level, we're going to go up to the URL address bar, and we're going to edit the address bar a little bit. Right now it says natus0.natus.labs.overthewire.org. We want to edit it so that it says natus1 instead. So just go into the address bar, highlight the number 0, and replace it with the number 1. After we do that, hit enter, and then we're going to see a new message. So it says Natus1, the site is asking you to log in. So this time we're going to be using a different username. So the last level we used the Natus0 username. This time we're going to have to use the username Natus1. So here in the username field, type in Natus1, and then in the password field, paste in the password that you got in the previous level. So remember when we copied that password? Now we're going to paste it. So hit right click, paste, and then click on sign in. Okay? So if you're able to see this message over here, you can find the password for the next level on this page, but right clicking has been blocked. Please type in the chat, I'm on level 1 now. Smiley face. If you're having trouble with the password, we have a little GitHub page, and the GitHub page is over. Where is that GitHub page? Hold on, let me get it. It's right here. And if you access that page, you're going to see all of the passwords and usernames for the Natus levels we're covering today. So we've got Natus level 0, Natus level 1, and if you're having trouble, you can just copy the password from here. Otherwise, so on Natus level 1, it says you can find the password for the next level on this page, but right-clicking has been blocked. So you can try right-clicking on the page, and it says right-clicking has been blocked. If for some reason you cannot use the right-click to access the page source, how else could you access the page source? Does anybody know? So if you know how you can access the HTTP page source without using the right click, please let us know in the chat. In the meantime, I'm just going to take a sip of water. Just a second. User Deathwish on Twitch says Control U. That's correct. So before we talk about this, before we do this, we can actually do some search. So we can search using Google, and we can search for HTTP source access method. Oh, this is going to give us some funky stuff. We can also ask ChatGPT. So ChatGPT, we can ask it a question like, if we cannot right-click on our web browser, how else could we access the web page HTTP source? Okay, and if we ask this question, we're going to get a bunch of different answers. Use the browser's keyboard shortcut, access developer tools, view source through the URL bar. Oh, you know what? This is a very good method as well. We can also do it directly from the URL bar. It's view-source and then colon, and then that's going to be put in front of the regular page. So let's try that. That's kind of a new concept. So over here in the URL bar, you can do view-source and then colon and then nanas.labs.this. So give that a try. So you can do it like this, but otherwise you can also use the Control U keyboard shortcut, like what Deathwish gave us in the chat. But either way, you're going to come to this page, and you'll notice that this is actually view source. This is going to be the name of the URL right here. But in this way, we access the source, and in the source there's the password for the next level and another HTTP comment. Okay, so all we need to do is we need to get this password and then copy it. And before we go to the next level, let's talk about the method we use to access this page. So about HTTP source code, for web app testing, looking at the HTTP source code allows us to find interesting directories, developer comments, and more. So if you're a security tester, you can find all sorts of interesting stuff inside the HTTP source. So in this level, we're doing some lateral problem solving. So when hackers encounter a locked door, they look for an open window. We can look at web app security in terms of checking which doors and windows are locked and which can be opened. So if for some reason we're doing web app security testing and we find that we can't use one method, we should check and see if we can use other methods to spot ways into the application instead. So this is where a security tester's most powerful weapon, research, comes into play. So when I see research is, the web app security tester's most powerful weapon, it sounds kind of corny, but if you didn't have access to stuff like ChatGPT or Google, it would be difficult to do web app security testing, because you do a lot of research when you're doing security testing, because you're going to encounter a lot of technologies or technologies and software that you haven't seen before, and that's where research comes in very, very handy. So once the obstacle to a problem is discovered, we can research a way to overcome the obstacle or a method of bypassing it. So this is an example of using ChatGPT. You ask it, how else can we access HTTP source? Okay, so that is lateral problem solving with NATIS level 1. Let's move on to NATIS level 2. So over here on the NATIS 1 page, we're going to edit the URL so that we're going to NATIS 2 instead of NATIS 1, and then we're going to move on to the next level. Okay, so natis2.natis.labs.over-the-wire is asking you to sign in. Remember that the username is always going to be the NATIS level, so because we're trying to access NATIS level 2, the username will be NATIS2. And the password is going to be the password that you just copied. So Control Paste, right click, select Paste, or Control V to paste in, and select Sign In. Okay, so you should see NATIS 2 if you are on the NATIS 2 page. And please let us know if you are on the page, if you can access it, by typing in NATIS 2 smiley face in the chat. If you're having some sort of problem, then please let us know in the chat as well. We'll try to help you out. And if you're having problems getting the password, you can find the password on this GitHub page. Okay, so it says here that there's nothing on this page, but we know that's probably not true. But what we can do is we can do some examination of the HTTP source, and let's do that. So remember, you can access HTTP source by either right-clicking and selecting View Page Source, or you can use the Control U keyboard shortcut, or you can just go into the URL bar here and type in view-source : and then hit enter. Either way, we're going to get access to the HTTP source here. So everything up until here we can safely ignore. It says this stuff in the header has nothing to do with the level, and the header is everything from here until here. So this is actually the password for our current level, so this is not the password for the next level. So everything from here to here we can ignore, but everything from here to here is fair to examine. Okay, so let's take a look at lines 11 till 17. So there's something in here that's going to help us get access to the next level. Can anybody identify it? If you can identify which line has the important content, please let us know in the chat. It's somewhere between lines 11 and line 17. If your answer was line 15, then you are correct. So what this is an image source. So everything on the web has to come from somewhere. All of the content, I think what are these called? Assets. So every asset that's being used by the website has to come from somewhere. So in this case, the image has a link, and the link is to this directory right here, files/pixel.png. So when it says there's nothing on this page, that's not true. There's this pixel.png over here. So this is an image file. If we click on this, we're going to see that this is an image that is exactly 1 pixel big. But aside from that, there's something very important about this link. So this link right here, there's something very important about it. Can anybody tell me what the importance of this link is? Okay. So in order to, before we go over the importance of this link, let's go over the concept. So the concept we're going to be exploring in this level is directory indexing. So this is a concept inside of websites. And what directory indexing is an insecure setting on websites that allows users to see the file contents of web directories. Although it is quite rare to encounter this issue on modern websites, it's still very common to find on older websites. So basically, if you've been around the internet for a while, you might have seen this kind of thing. It's going to be something called the page is going to show the word directory listing, and then a bunch of files that are available in the directory. So this kind of vulnerability is also it's either called directory indexing or directory listing. And it basically means if you go to a directory inside of a website, it's going to show you every file in the directory. So if we go back to this page over here, we know that this pixel.png file is in the directory, but it's in this directory called files. So what we can do is we can manually navigate to the files directory and see if there's anything else in here. So we do that by going over to the URL address, and we can navigate so that it only says files. So it's /files. We can also put a slash at the end to make sure that this is a directory, and then hit enter. Okay, and then it says index of /files. So this is directory indexing. So directory indexing means that we can see every file in the directory, and that there's nothing preventing us from accessing the files as well. GX000 says that somebody's here. Nice to see, nice to see. GX00, let's give you a redeem. Let's hack the planet. Thank you very much.
Hack the planet! Hack the planet! Shut up and get in.
Nice to see you here. We're just talking about some very basic web app security concepts, and we're taking a look at this directory indexing. So we can see the index of /files over here. We see that there's the pixel.png file, but there is also this users.txt file in here as well. So we can click on it, and we see that inside this file, there's a bunch of usernames and passwords. So the format is username:password. We have Alice, we have Bob, we have Charlie, but we also have Nadas3. Who left that there? Well, somebody who didn't know how to set up their website is who left that there. So Nadas3 is the password for the next level. Nadas3, this entry is the one for the next level. So we can just copy this. GX00 says someone is about to get fired. Well, I mean maybe, but we can copy this, and this is going to give us access to the next level. So just right-click copy, and then we're good to go. So GX000, if you're interested in some more challenging hacking concepts, we're going to be doing some free hacking against virtual machines from the VulNyx website in about half an hour or so. So at 6 o'clock local time, we're going to be starting our free hacking session. So if you want to do some more advanced stuff, then please stick around for that, okay? Okay, so we can copy this, and we can use this to access the next level. So over at natus3.natus.labs.overthewire.org, we can use this password with the username natus3. Natus3, input the password, and click on sign in. If you're having, if you want to join in, you can always go over to our GitHub page, and the GitHub page has all the credentials for the Natus levels over here. And if you are able to access the Natus3, if you're able to access the Natus3 page over here, please type in the chat Natus3 so I know that you are following along. Natus3 smiley face. Okay, so we'll give it a couple of seconds for everybody to catch up. GX00 says, I don't remember the answers, but I'm pretty sure I've done the Natus challenges. Yeah, I mean, a lot of people have done these Natus challenges. They're very popular for beginners web app security, yeah. But you know, I think if you do the VulNyx challenges, they've got a lot of web app stuff there as well, and some of it's pretty diabolical, as far as I remember. All right, so Natus 3. Once again, it says there's nothing on this page, but we know that's not true. So what we're going to do is we're going to take a look at the HTTP source, and we can do that with control. Sorry, it's let's try the keyboard shortcut. So we know if we're using Firefox or Chrome browser, we can do Control U as the keyboard shortcut to see HTTP source. And over here, we know that we only need to pay attention to everything after the header, and this is the header over here. So what we're going to do, what we need to pay attention to is going to be right here. So it says there is nothing on this page, but in the comments it says no more information leaks. Not even Google will find it this time. So this is very interesting, and it's actually referencing a very specific technology. If you know the technology, please type it in the chat, but if you don't, that's fine. What we're going to do is we're going to do some research. So if you were to grab this comment over here, whoops, let me highlight that again. If we were to highlight this and copy it, and we were to ask our know-it-all friend ChatGPT, we saw this comment on a web app security CTF site. What could it be talking about? And then we supply the comment. Let's see what ChatGPT has to say. Okay, so just really quickly here, it says, the comment suggests that the web app previously had an information disclosure vulnerability, potentially revealing sensitive files or directories to search engines like Google. In a CTF context, this could indicate that a sensitive resource or hidden path exists but are intentionally not indexed by search engines. So some ways to investigate further, it says check robots.txt. The site might be using a robots.txt file to hide certain pages or directories from search engines. Okay, so let's talk a little bit more about this. So robots.txt, okay, before we talk about robots.txt, a little bit more about directory indexing. If directory indexing is enabled and a malicious user is able to discover different directory paths on the website, either through guessing HTML source analysis or directory busting, then sensitive files may be discovered, stolen, or otherwise abused. So let's take a look to talk a little bit about HTTP requests. So HTTP is the backbone of the internet, and all web browsers receive web page content by sending HTTP requests to web servers. So every computer on the internet that is serving HTTP pages is called an HTTP server or a web server, and every web browser is going to send a bunch of HTTP requests to those web servers and receive something in return. In return, the web servers send the web browser an HTTP response, which is rendered by the browser and presented to the user. Each HTTP request is made with a specific HTTP method, which tells the web server what kind of interaction you want from it. For example, when we send a request to the Natus website, we are usually sending GET requests. So we want to get some information from the website, and in response, the web server is going to send us the response, which has the website information. The most common HTTP method is the GET method, which retrieves the contents of web pages. The web server will always return an HTTP status code with its response in the form of a 3-digit number. Any number in the 2XX range is considered a successful response. I think I need to take a little sip of water. Just let me do that really quickly. Okay. Just took a little drink. Take a big sip. Thank you very much. GX says 0. Okay. So we're talking about, hold on. So in the form of a 3-digit code, any code in the 2XX range is considered a successful response. So we're talking about robots.txt. Search engines such as Google, Yahoo, DuckDuckGo, etc. use programs called robots to visit websites and map out their web pages. However, this may cause sensitive areas of the websites to appear in search results. So if you got some secret directory on your website where you're doing secret stuff, you don't want the robots to index that web page. So in order to prevent this, website administrators can add a file called robots.txt to their website, which specifies which directories and/or pages of the website are off limits to search engine robot programs. Unfortunately, if malicious users know how to find the robots.txt file, the contents of the file could potentially lead them to sensitive areas of the website. Okay, so now that we know that this robots.txt file can exist on websites, and over at Natus level 3, it says not even Google will find it this time, which is reference to the Google robot. We can go over to natus3.natus.labs.overthewire.org, and we can give it another endpoint, which is called robots.txt, to look for the robots.txt file. So what we do is we essentially add this to the end of the address. So it's /robots.txt. So just modify the end of the URL here so that it includes /robots.txt, and then hit enter. And then we should see this right here. So this is an example of a robots.txt file. In fact, let's take a look at a regular robots.txt file that exists on a real website. So if you go to google.com/robots.txt, this is the robots.txt file for the Google website. So Google has a lot of different websites. Sorry, a lot of different directories and endpoints that it wants indexed, and it does not want indexed. So we can take a look here. And it says user agent star. User agent is basically the browser type, and star means all. So you can access the site using all browsers, but it doesn't want us to index this search directory. It wants us to index search about and search static, and it allows and disallows all of these different endpoints over here. So this is letting search engine robots know which directories it can and cannot index. So this is the official google.com robots.txt file. But over here in the natus3 robots.txt file, should or should not. Okay. Thank you very much, GX000. But over here we can use any user agent, any browser to access the site, but it disallows the indexing of this directory right here, which is called /secret, where the e's are replaced with 3's over here. So now that we know that this directory exists, what can we do? If you have an idea, let us know in the chat. Okay, so now that we know that this directory should not be indexed, we could try accessing this on our own. So there's no link. Replace the 3's, replace the 3's with e's. I don't think that's going to work, but we could try. So this is a directory that on the website that we could try accessing. If we go over to here and replace robots.txt with the secret directory here, and we replace the 3's with e's, that doesn't work. That's not found. But if we replace the e's with 3's like this, then we can access this directory right over here. And in this directory, we see that there's directory indexing enabled on this website as well. So we can see everything in the directory. GX00 says, someone else is getting fired. Maybe. Although this is intentional over here. So we see here that the directory contents, we can go back up to the parent directory. We can also access the users.txt file over here. And inside the users.txt file, we see the entry natus4 with this password right here. So this is the goal of the exercise. We just copy that, and we should be able to use this to access natus level 4. So we're not going to cover natus level 4 in today's session, but we can navigate there ourselves if we wanted to. So we would just edit this this URL so that it says natus4 instead. Natus4 is asking you to log in. Okay. The username is natus4, and the password is whatever we just got. Paste it in and click on sign in. Okay. So everybody, this is the extent of everything we're going to be learning in today's session, but we're going to be doing some practice now. So we love to use picoctf to do different exercises, and there are a few different exercises. GX00 says, looks like they're running Apache 2.458. I believe that's vulnerable to a denial of service attack. I wouldn't suggest doing actual hacks on these educational websites. It's kind of bad form, but it's interesting of you to point that out. Okay, so we're going to be doing some exercises over at picoctf. If you're not already logged into picoctf, you can go ahead and access it from this website right here. And here you can log in. At least I think I can log in. Is picoctf offline? Oh, it better not be. Otherwise, I'm going to have to log in again. So everybody, let me know if you're able to log into picoctf. If you're not, then it's not just my problem. You're getting a login page. Okay. You don't have an account. Oh, you don't have an account at picoctf? You know, there are a lot of good little exercises you can do at picoctf GX000, and yeah, you can. I mean, you probably have access to this page. picoctf register over here. But yeah, if you don't already have an account over at picoctf, it's actually a very fun website. You can do all sorts of fun little challenges there. But okay, I can log in. Oh, great. I don't need to. Okay. GX00 says, I've watched you do things before. Yeah, okay. I do like picoctf a lot. And we're going to be doing some basic web app challenges. So we're going to go for the easy challenges in the web exploitation category. And otherwise, we're going to be doing where are the robots? So this the name of the challenge might give away what we're doing here. But what I want you to do is I want you to navigate to this page. And in picoctf, we're also going to navigate to that page. Neospring says, Ribbit, Neospring, nice to see you here. We're just doing a couple of easy web app security challenges because we learned about a few different concepts in our class, such as robots.txt and doing directory indexing and stuff. Okay? So it says here in the description, can you find the robots? If you don't have an account over at picoctf, you can make one, and then you can access the challenge from here. So it says, can you find the robots? Actually, I think you don't need to have an account to access this website, but I could be wrong. Let me copy the link. Copy, and then let me see if I can access this from a private window. Yeah, you don't need to be logged into picoctf to look at this website. So go ahead and access the website from here. And it says, can you find the robots? So there's a link over here, and there's another link over here. So you just need to put that link in a new tab. And then it says, welcome, where are the robots? So we just talked about robots.txt, and we know we can access a robots.txt file if it exists on the website by going back up to the URL bar and then manually adding /robots.txt to the end of it. So hit enter. And it says disallow this directory right here. Actually, it's not a directory, it's a HTML page. So now that we know this, we can actually highlight all of this and copy it, and then replace robots.txt / and paste in this GX00 got the flag. Okay, great to see. And it's the same flag as mine, so we can actually share these flags. I guess picoctf is okay with people sharing flags. It says, guess you found the robots, and then this is the flag right here. If you have an account over at picoctf, MSEC is applauding. I think it's because I used your URL. Oh, well, I don't know if they individualize. I don't know if they individualize these URLs. I think this is a static one. But anyways, where were we? So over at the Where's the Robots challenge over here, if you have the flag, you can go over to the flag submission field and paste in the flag and then click on Submit Flag to finish the challenge. Okay? So we've done this challenge many times because I teach this. GX000 says, do they have 61,000 challenges? Is that a... I'm not too sure what a 61,000 challenge is. So let me check with Google. 61,000 challenge. What is this? Your challenge number in the URL was like 61,000. Oh, really? Oh, I mean, I'm not too sure how they set that up. But anyways, let's do, I think we have time for one or two more challenges before we finish out today's session. Try 60,916 for science. Okay, well let me grab let's grab this and then see if we can paste this in. And we're gonna try 16? Bad gateway. Yeah, okay. Well, I mean, the people who organize the Pico CTF challenges, they should be good at web security, but you never know. Anyways, the next challenge we're going to cover is the includes challenge over here. Okay, and after that we've got quite a few if we really wanted to. Let me grab this challenge and give everybody the link. FF fuzz it. I don't think we should be running our legitimate security tools against the educational website unless it's telling us to do that. But anyways, let's access this challenge. And welcome to the stream, Neospring. Let's do a fun little redeem. So these are my favorite birds, the Stellar Jays. Okay, so let's take a look at the includes challenge over here. It says, can you get the flag? Additional details will be available after launching your challenge instance. So this one has individualized websites. This is for people. Maybe we should do. Okay, who in the chat has a PicoCTF an account? If you have a PicoCTF account, please type PicoCTF up in chat. If you don't, please let us know that you don't, because I like to do challenges that everybody can do. But anyways, so if you come across this challenge, the first thing you want to do is you want to launch the challenge instance, which is going to spin up a website for you. Neospring says, I did the first one where you download the file. Oh, okay. Let's see. So, okay, so after you start the instance over here, it's going to give you 15 minutes to solve the challenge, and you can go to this website and see what you can discover. So if you want to play along, but you don't have a PicoCTF, account, you can go ahead and go to this website, but you're not going to be able to use the flag. But just getting the flag should be good enough. And let's see if we can get the flag. Okay. So it says, so this web page over here, it says on includes many programming languages have a directive often called include. that causes the contents of a second. So this is basically importing code into your existing file, and we can click on the button. It says say hello. This code is in a separate file. Okay, great. Okay, so everybody, if you're well, go ahead and see if you can get the flag. If you're familiar with the web app challenges, you should be able to get the flag. Let me take a look at the source. So on the page source, we see over here there are a couple of different files that are referenced in here. So we've got our style.css file, and we could actually take a look and see what's in there by right-clicking and putting this in a new tab, and the script.js file as well. So the script.js file is probably where the code for this button over here that says hello when you click on it. So we can put this in the new tab as well. Okay, so let's first take a look at the CSS file. So the CSS file has part of the flag. So it's got picoctf inclusivity 1 of 2. So we can just copy the flag here, and then we can go back to the challenge page, and on the challenge page we can paste in the first part of the flag just so we can keep it here for safekeeping. And then we can go over to the second link over here, which is the JSS page. Okay, so GX00 seems to have the rest of the flag. So this is the JavaScript that activates the button over here. Alert, this code is in a separate file, and we also have the second part of the flag here. So we can just copy this and then go back to the challenge. And in the challenge, we can paste in the second part of the flag and then click on Submit Flag. And then, so picoctf has been having some connectivity issues with me today, so I might have to submit the flag a couple of times. Just for fun, click on it again. But we're gonna do one more challenge before we finish out today's session. So I hope everybody has been learning some new stuff about web apps and how we do testing against them. Let's see. Click on that. Okay, we solved the challenge. Let me start closing some of these tabs because I have a lot of these tabs open. Okay, that's better. So let's do the secrets challenge over here. So the last challenge we're going to do today is this challenge here, and you can access it from this link. And the challenge is this one. Okay, so the secrets page, the secrets challenge here, we have several pages hidden. Can you find the one with the flag? Oh, okay, this one, I remember this one. Okay, so we're going to launch the instance, and it's going to start up a website, and the website has a bunch of different pages. So I'm going to, everybody who wants to participate, you can take a look here, and if you're able to get the flag, you can paste the flag into the chat just to let us know that you've completed the challenge. But so this is going to test our skills. So we've got a web page, and it's got a couple of links. So we've got our home page, we have our about page, and our contact page. So if we take a look at the source, then we see a couple of links. There's about and contact, and we also have there's a /secret/assets directory in here as well. Okay, so everybody, if you want to race me and you want to see if you can get to it before I get to it, you can go ahead and try to solve the challenge before I do. But we can access this secret directory over here. And this is the JPEG. This is the JPEG which is on the landing page, but it's also inside this secret/assets directory. We can try to access the assets directory directly. We can just delete the name of the file, the JPEG, then hit enter. And this is 403 forbidden. So we don't have access to the assets directory, but maybe we have access to the secrets directory. So we can just get rid of the assets portion. And we get this message. So let's take a look at what this page looks like on its own. So finally, you almost found me. You are doing well. Okay. I have no idea what I'm doing, but I know I'm doing it really, really well. Okay. All right. So once again, there's a reference here to /hidden/file.css. Okay, this link right here doesn't have anything to do with the challenge. It's not on the website. And I guess we can go to this file right here. So just highlight this hidden/file.css and right click it and put it in a new tab. And we've got file.css, CSS files. Is there nothing here? File.css, it looks like there's nothing here, but we can navigate to not file.css, but just the hidden directory. And ooh, what is this? This looks like Facebook. This looks like some sort of sign-in page. So /secret/hidden is some sort of sign-in page. But let's take a look at the source. So we've got secret assets popup.js, super hidden login.css. So we could try accessing these. So super hidden, we're going to put that in a new tab. And secret assets popup.js, we can also access that in a new tab. So let's take a look at /secret/hidden/super hidden login.css. So this is a CSS page, but we can also just access the super hidden directory. Okay, and there we find the actual flag. Finally, you found me, but can you see me? So because we're looking at the source, we can see it, but because this is in, I'm not too sure why we can't see it here. Class equals flag, but we can get the flag in here and then copy it and then go over to the challenge page and submit the flag. And we're done. Okay. All right. So everybody, we solved a few challenges. We got used to working inside of web apps and doing security testing on them in a couple of different ways. And let's go on to our summary for today's lesson. Let me get out of here. We are this. So let's review the web app exploitation concepts we learned in today's workshop. So we talked about some lateral problem solving. The most important skill to develop in cybersecurity is researching. Google and ChatGPT are two powerful research tools, and use them wisely. And we talked about directory indexing. It's a vulnerability on websites that allows users to see the contents of web directories, which can lead to sensitive data exposed to arbitrary website visitors. Lastly, we talked about robots.txt, which is a special file included on certain websites that indicate which files on the site can and cannot be indexed by search engines. It can be abused to point malicious users to sensitive parts of the website. What's next? In the next HackerFrogs After School Web App Exploitation Workshop, we'll continue learning web exploitation skills with the NATA CTF. So everybody, that's it for today's HackerFrogs After School Web App Exploitation Workshop. We're going to move on to the last portion of today's live stream, which is going to be some free hacking against a VulNyx machine. And everybody who attended for the Web App Security Workshop, thank you very much. And we're going to be working on this website next. This is a website where you can download vulnerable CTF boxes and do some hacking against them. So that's what we're going to do. So the box that we're going to cover today is called Wicca, and I think it is something like machine 40 something on the website. No, it is machine 52. Okay, so this is a quote-unquote low-level challenge. These are the easiest challenges on the website, and sometimes I get stuck on low-level challenges from this website, which illustrates more about my skill than the designer's skill. So what we need to do is we need to spin up this machine on our virtual machine network. So I've got the Wicca machine running, and it is running at IP address 10.0.2.44. So if you want to join in along with us, you can go ahead and download the CTF box and put it on your own network so you can do your own security scans against it. For this portion, I'm going to turn the music back on, and we're currently listening to the Mass Effect 2 soundtrack. And I really like the music from Mass Effect 2. It's one of my favorite game series. It's got some great moody music. So okay, so let's do some network hacking. So the machine is located at 10.0.2.44. Let me put this away. So we were doing some man, I kind of don't like that I have to stop doing my testing against this other machine I was doing testing on, but it's okay. Okay, so the first thing we like to do when we do our testing is exit out of here, quit, is we have to do an Nmap scan to figure out what ports are open on the system. So what we're going to do is we're going to Nmap with these different parameters against the vulnerable web server. Server rather. So we're going to check common scripts with -sc, get versioning information with -s capital V, all ports with -p-, very verbose output with -vv, and we're going to get very quick speed with -t4, but it's not going to be too quick as to get false positives. Nmap is going to scan the server and reveal to us what open ports are on the server. So, oh, that's unexpected. There's port 5000 on this. Okay. So, what do we have? We have... We're getting... This is interesting. Okay. So this is the first machine in a while that has had a port that wasn't just port 22 and port 80. So we see here that port 22 TCP is open, which is associated with SSH. Port 80 is open, which is associated with HTTP. Port 5000, I'm not sure which service that might be, but the rest of the scan will tell us. So we've got OpenSSH on port 22, version 9.2. So this is very, very up to date. We've got port 80. This is an Apache server, version 2.4.57. This is probably up to date and not vulnerable to anything, but we got get, post, options, and head as our methods. And we got port 5000, which is a Node.js server. Okay. Express middleware. So Node.js is a particular framework for JavaScript. Aside from that, I don't know too much about Node.js, but we can do some scanning against it. So first of all, now that we know that these ports exist on the server, we can start doing some enumeration. The first thing I'll do is I'll do some web enumeration against the default HTTP port, and I'm going to do so with Nikto. Nikto GX000 says that's not an up-to-date Apache. I think it might be up-to-date enough so that you can't get like remote code execution off of some weird vulnerability. But I actually don't work with Apache servers on a regular basis. But GX000 probably knows better about that stuff. So let's do a Nikto web app vulnerability scan on the server. So Nikto is an old tool, but can sometimes get you some very good low-hanging fruit vulnerabilities. So it's going to get us the Apache, the software version, and the software and the version. It's going to get us our allowed HTTP methods. We've got an images directory, so I guess we could check that out. Aside from that, we don't find anything else, but we know that the images directory exists, so we could try checking that out. So let's go over to 10.0.2.44, and we're looking at images. So we don't have very much here, it's just this logo.png. And it's just got this VulNyx logo over here. So that's probably not anything we need to pay too much attention to, but who knows? Okay. So the next thing we can do is we can start, well, we can take a look at the landing page. Maybe there's something on the landing page. So here, we're just going to navigate to the landing page. Oh, it's a Debian default page. It's an Apache 2 default page. Okay, so this probably doesn't tell us anything. If we take a look at the source, it probably isn't going to lead us anywhere. We've got an icons directory, but aside from that, not very much exciting going on here. So we can do some other scanning. So we're going to do some GoBuster scans. GoBuster in directory mode. And let's just do the medium version. So this is a standard word list that we're going to check against. It's a directory list lowercase. Anyways, let's try this. When we do GoBuster scans, we can specify which extensions we want to check for. We've got a bunch of different file extensions we could try to enumerate. So such as XML, TXT, HTML, PHP, zip, JS, back. This should be okay. This should be sufficient for unless we're looking for very specific technologies. Let's see. Oh yeah, no, my whole terminal is in. Yeah, it should be in view. But let's see if we can find anything. So we find immediately. We find images directory. We find a JavaScript directory. In another tab, we can start doing enumeration against port 5000. So we'll do Nikto on the same IP address, but against port 5000, which is hosting the Node.js website. So no banner received, X powered by header express. So we can be fairly certain that this is a Node.js framework website. So over here, this is going to take a while because we're looking for all of these different extensions, and each extension is going to increase the scan time by 100%. So 1, 2, 3, 4, 5, 6, 7. So this is going to be 800% slower than scanning without any of these extensions. But so I guess we've got get and head. Let's try manual enumeration on this port. So over at this website, we're going to manually navigate to port 5000. So this is a login website, okay? So VulNyx, what is your name? I guess, what is my name? The name of the box is called Wicca. So let's try Wicca. It just says welcome Wicca. We have a token. We get a token and we get a parameter name up here. So name equals Wicca and token equals this number over here. So I don't know what we can do with that. Let's try entering some other names. So let's try test. Welcome test. The parameter is changed and the token number is changed. So I wonder if there's some interesting cookies that are being assigned. So I'm just going to take a look and see if there's any cookies in my there's any associated cookies in here. So I'm going to go to my web developer tools and I'm going to go to my storage, and for this website it doesn't look like there's any cookies. So what else could we try? We could try some OS command injection. Okay, welcome, who am I? Maybe that's not it. Token equals this. We could try some local file inclusion. So in the name parameter here, we can just see if we can access the etc password file. Nope, that's not it. So let's take a look at the page source. So token value, we've got sources, we've got interesting. So another thing we could try is we could take a look at the Wapalizer extension. It tells us the HTTP server version, but nothing else. Okay. So it doesn't tell us very much. Okay. So Nikto has come back. It tells us that W key. This is probably a false positive, because most of the time, I think I've seen this before. I mean, I can test this. Oh. Well, I mean, this is probably an error message that errors out for whatever. Yeah. So this isn't necessarily... No, this is not a vulnerability here. And it's also not a valid endpoint. Okay. So... let's try using some curl commands. So I'm going to curl to 44. Yeah. On port 5000. and see if we can get some interesting headers. So HTTP. Okay, we get an E tag powered by Express. Okay, so that doesn't tell us too much. But let's see what happens if we just contact it on the regular web server port. That's a lot of stuff over here. So this is... I don't think this is super important. Okay. Now, let's take a look at the GoBuster scan. So the GoBuster scan came back. We've got a JavaScript directory and not much else. So the images directory... Let's try checking out the JavaScript directory. But in the meantime, we can fire off a second GoBuster. So the second GoBuster is going to be looking at port 5000. So we just need to adjust this so that it points at port 5000 and see if we can get any additional directory busting done. Okay. So let's go over to the JavaScript directory. So this is forbidden. I don't have access to permission access this resource. So that means that we're probably going to need to do some more scans. So we're scanning port 5000. I think we also want to try scanning the images directory is open. What about the images directory on port 5000? Images / images. This is on port 5000. Cannot get images. Okay, so I guess another thing we could do is we could run yet another GoBuster scan. So GoBuster in directory mode. And then we're going to scan inside of the JavaScript directory and see if we can find anything in the JavaScript directory. Oh, there's a couple of directories inside of the JavaScript directory. We've got events and util. Let's see if we can access those. JavaScript events. Nope. This one is a no-go. And util. Also no-go. So right now we have the web app on port 5000, and we could try testing this for more vulnerabilities. So here we've got our test and our token that we get after we submit this. I want to try. Let me take a look at what the source is for this. Open the image in a new tab. So images logo.png, this is legit, but if we try to just go to images, it says cannot get images. So I'm going to try opening up Burp Suite. So Burp Suite might give us a better idea of what's going on with this web app, especially the one that's working on port 5000. So let's start up Burp Suite and then start up the Burp Suite web browser. Okay, so we're just going to go over to proxy open browser. That might take a little while. We're going to go to 10.02.44 on port 5000. Okay, this is the web app that we're taking a look at. Okay, so now that we've navigated there, we're going to go over to HTTP history, and we're going to send this to the repeater so that we can start tinkering around with that. So this font is very small. I think I can go into the settings and make the font bigger for everybody to take a look at. So I'm going to size inspector, and okay, so I'm going to make this, I'm going to change this font. I'm going to make it 18 point font. Okay, so that's much bigger. Maybe it could be bigger. Maybe this is big enough. And the display, I'm also going to make this bigger. I'm going to give us 18 point font here. Okay, so that should be easier for everybody at home to take a look at. Okay, so let's send this off. Powered by Express, eTag, VulNyx Lab. What is your name? Welcome something something. You know what? I'm going to go over to ChatGPT and I'm going to ask it a question. So the current CTF challenge we are doing is against a web server that is running an Express Node.js server, and the challenge name is Wicca. What could these names be a reference to? It's thinking. Okay, so okay, maybe it's not going to give us anything. Root handling can sometimes hide hidden endpoints within an app code's code structure. Look for hidden or mystical sounding roots like magic, secret spell, or Wicca. Okay? Express apps often use Express Session to manage their user sessions. If the app's session configuration is weak, like guessable cookies or insecure storage, there might be ways to manipulate the session data for privilege escalation. Okay, so let's go back. So is there a Wicca endpoint? There's no Wicca endpoint. Okay, so here we can start enumerating for some vulnerabilities. First of all, let's see if, let's get rid of this. So the JavaScript directory, we're able to find HTML events util async, events util async. Let's try scanning inside of the events directory. Sorry about that. Oh, we found an events.js file. Okay, so let's check that out. Okay, so JavaScript events.js. Okay, so this is what is this? This is called events.js file. Let's ask about this. What is the events.js file? In a Node.js application, the events.js is a core library file related to the event emitter class, which is central to handling events in Node.js. Okay. Wait, this looks like in this account, an event greet is defined, listened for, and triggered, resulting in the console output of hello Alice. This looks very similar to the output from the app on port 5000. So the app on port 5000, you type in a name like Alice, and it says welcome Alice. So that could be related to the events.js file. In the CTF context, understanding how the event emitter works could help you identify misconfigured or vulnerable event handling that might be exploitable, especially if user input affects event management or data handling. Okay. Alright, so events.js, we've got our HTML stuff over here. We need to keep in mind the other directories we found as well. The other directories we found were util and async, so we'll be scanning inside of those directories next. Let's see, GX00 says, I'd focus on the token. I don't know what it's for, but it's sus. It is sus. Okay. Well, okay, let's... we haven't had a redeem in a while, so let's get another beautiful bird up on here. And this is the northern flicker woodpecker. Anyways, okay, so this is finished scanning. I'm just gonna wait out the last couple seconds of this scan, and then we'll start scanning inside the util directory. Okay. So we're not scanning inside the events directory, we're now scanning inside the util directory. Okay. And there's a support directory inside of this one, okay. So util.js. Let's check out util.js. util/util.js. Okay, so I think this is another Node.js specific. It's another Node.js specific file. So let me ask ChatGPT about it. What is the util.js file? In a Node.js application, util.js refers to a utility module that provides various helper functions and methods used throughout the application. Okay, so if we could get a particular version of Node.js, then we can probably figure out if there's some sort of exploit that we need to, there's a specific exploit we need to run against this. But what is the... So there's also the async directory. Maybe we can just look inside of the async directory right now. So over here. So we've got async, async.js. Okay, so this is probably another Node.js specific file. Let's ask ChatGPT. What about the async.js file? Async, let's see. Async.js file typically contains functions and utilities related to asynchronous programming. Given that Node.js is designed to handle asynchronous operations efficiently, such a file may implement patterns, helpers, or specific functionality that leverage JavaScript's asynchronous capabilities. Okay. I really wish I knew more about JavaScript. Unfortunately, I don't. That's why I have to ask ChatGPT for all this advice. So we've got events, we've got support, util support. Okay, so we've got our hidden token value. Let's grab this right here. Actually, let's just grab everything. Okay, so we have an Express web page on this web server, and its source code is as follows. Paste in the web code, and then add in another little comment. The other comment is if we input the name Alice, then the URL changes to this. Okay. So the provided HTML source code is a simple web page that appears to include a form for user input. Okay. So HTML structure, form elements, welcome message. User input behavior. When a user types Alice into the input field and submits the form, the browser likely sends a request to the server with the entered name and the hidden token as part of the query parameters, resulting in a URL. The resulting URL indicates this. So there's a name parameter and the token parameter. This appears to be a dynamically generated token value that changes every time a form is submitted. Okay. So implications and potential vulnerabilities. So the presence of the token suggests some sort of CSRF protection or session management. However, if the token is predictable or easily guessed, it could lead to vulnerabilities. Parameter injection. if the server-side code does not validate or sanitize input, we could do cross-site scripting or server-side request forgery. If you're conducting security testing, you might want to test for XSS by submitting script tags. Oh, okay. Yeah, we could submit script tags. Let's see if this changes anything. Nope. But strangely enough, did it sanitize the script tags? So what are some other script tags that we could install? How about script and URL encode? Yeah, we could try URL encoding, but I want to figure out if we can send like cross-site scripting payload. I don't remember my cross-site scripting payloads anymore. Alert XSS payload. Oh yeah, right. Okay. So back here. Something like this. Oh, okay. We have cross-site scripting, but I don't know how cross-site scripting helps us get. Okay, so we have confirmed cross-site scripting on the website, but I don't know if that actually helps. How can we leverage cross-site scripting into? How can we leverage cross-site scripting into like remote code execution? Because the goal of the exercise is to get access to the web server, like get RCE. Let's ask ChatGPT. It knows everything. So if we have XSS on this web page, how could we leverage this into web server file exposure or some other form of remote code execution? I don't think so GX00 says, I don't think he can, but it would suggest maybe there's no input validation. So if there's no input validation, we could try to do OS command injection. So we could steal cookies? I don't know. So stealing cookies from sessions, making unauthorized requests for... okay. Once you have XSS, you can make requests on behalf of the victim user. If the user has privileges or admin, you can execute actions. Post include... So this is server-side request forgery. RCE on the inputs. Slash sensitive endpoint. I don't think sensitive endpoint exists on this particular server. Loading external scripts. So you could inject a script tag that loads an external JavaScript file hosted on an attacker-controlled server. This file could contain further malicious payloads. Okay. Remote code execution via stored XSS. If the XSS vulnerability is stored, you could craft a payload that allows for RCE when an administrator visits the page. So this is probably not the way to go. because there's nothing on the system that that is going to. Well, I don't think there's anything that's going to simulate an administrator logging into the website. Exploiting local files, local file inclusion. So this is something that might be the case. So if the web application has local file inclusion, you could use XSS to craft requests and retrieve local files. So file equals something something something, etc. password. Okay, well we could try this. I don't know what the path we would use in this case, what it would be, but let's try. Let's try malicious XSS. Okay, so we've got our script tags. We've got our path to vulnerable endpoint. So the vulnerable endpoint is just the well, what is this? Is this index dot? Is this just index.js? No, this is not index.js. The vulnerable, okay, so GX00 says the vulnerable endpoint is the variable names. My guess would be something like this. So I'm gonna try just sending this and seeing if we can get some sort of result out of this. So that would be over here. Copied too much. What do you mean by copied too much? If you could give me an example, GX000, that'd be handy. Thank you. Oh, okay. Did I copy the nano header? I don't think so. No. It's yeah, just a trick of the light. But let's add in a few more of these dot slashes just for fun. Okay. Nope. Let's go back to the drawing board. So exploiting local files, DNS for binding attacks, remote code execution. So what about this loading external scripts? If you could inject a script tag that looks like an external JavaScript file hosted in an attacker control server, ask ChatGPT about injection attacks for Node.js. Okay. What about if we can execute SXS on the system? What are some Node.js injection attacks we could try? Okay, so let's take a look here. Oh, it's printing off so much. Okay, so if you identified XSS, you could try to execute a variety of injection attacks. Prototype pollution. This doesn't seem super appealing. Server-side request forgery. Okay, so this means that we could potentially have it. We could have the application run some malicious code that is located on our server. Command injection. So this seems like more appealing. So command injection here. Oh, okay. This seems like something that that I would be interested in. Allows user input to execute system commands using child processes. You can inject malicious commands that execute arbitrary code on the server. So API? Copy paste vulnerableserver.com. Well, I mean, we need to get this correct, right? Change the URL, of course. Let's okay, so vulnerableserver.com becomes I don't think it's an API endpoint. We're doing this is I think we would do something like this. Replace it with name or token. Name or token. Right. Name? Because that's a legitimate parameter. Okay, so let's copy that. Yeah, right. Okay, so let's go ahead and try this one. Nope. Script. Etc. Let's try another parameter name. So this is port 5000. This is definitely... Let's change this to token. Nope. Let's change it to something else, maybe API. No. Okay. Let's try something else. JavaScript injection in template engines. Remote code execution via malicious payloads. Okay, so first of all, what happened? So our malicious script tags. What does it look like in the URL after we do this? So alert XSS. So just for reference, this is what it looks like. This it doesn't like me to paste in this malicious stuff in YouTube. It let me do it in Twitch. So let's see, script name equal. That's a name one, okay. So name equals script something 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 and token. I think we need the. I think we might need the token as well. So maybe it's because we don't have the token. Twitch URL encoded it, so it's not exactly the same. Okay. Let's do. What would we do here? Okay, so can we put... You know, I'm curious to know if we can execute JavaScript with the script tags. Could we could we put a malicious reverse shell payload in the script tags? Okay. Oh, my voice is starting to get raspy. I need to have a drink. Hold on. Okay, so GX00 says could do token equals token and name equals payload. In this case, payload would be... What is this? Basic reverse shell example. Man, it would be so awesome if we could actually get it to run something like this, but I don't think it can. But you know what? Maybe we can dream. So over here, let's start messing around with this. Var shell equals get my IP. Let me. So. Oh wait, so this is... okay. So let me grab... Okay, so... kind of a long shot. Didn't quite work. Okay. So, let's see. GX00 said, good try, token equals token, and name equals payload. Token equals token. Order doesn't matter. Okay, order doesn't matter. So... execute. If the goal is to achieve a reverse shell on the backend server itself, a more sophisticated approach would involve exploiting a server-side vulnerability like command injection directly, or leveraging the XSS to manipulate the server in such a way that it executes a reverse shell command. So I'm probably not finishing this in one go. GX000, if you have an idea about what payload we should send to the server, please let us know. Just pointing out how if you couldn't figure out how to include the token at the end after your payload, you could do it before. Yeah, okay. So let's see. What are some of these payloads? You're reading. Oh, okay. You've got some JS documentation over here. Let's take a look. You know what I could do? I could just search for like a machine that somebody else has already done. Something like Node.js. Node.js, CTF, command injection. Node.js command injection examples and prevention. Okay. So Node.js RCE in a simple reverse shell. Okay, let's take a look at this article. It might give us some security problems. Okay. So if you want to know what article I'm looking at right now, it's this one right here. GX000 says you're going to need to go. No problem. I really appreciate you sticking around and offering advice, because this isn't my usual stuff that I'm doing. But let's send you off with Hack the Planet.
Hack the planet! Hack the planet! Shut up and get it!
But thanks for sticking around and helping out. If anybody else in chat has any suggestions as to how to tackle this challenge, I'd appreciate it if you typed in chat and let us know. So we've got. Let me know if you figure it out. Well, I might be working on this after dinner, after the stream is over. But thank you very much for the well wishes. Okay, so I URL encoded the command in burp repeater in order to get the GET request to work. For the sake of readableness, I show the commands not in the encoded form. Oh geez, this looks complicated. There is another way is to obtain a reverse shell with the child process module from Node.js. Okay, so we've got netcat, right? just to be optimistic, why don't we set up a netcat reverse shell listener? And netcat NLVP 443. Okay, and then maybe in Burp Suite, the Burp Suite browser here. We're going to do the alert, which gives us the JavaScript XSS. Okay. So from there, we can go into Burp Suite, and in Burp Suite, we've got our request that has the XSS payload, and we're going to send it to the repeater. So over here, what we can do is we can start playing around with what we send to the server. So if we send this, that's an XSS. Yeah, right over here. Okay, so otherwise, so a quick reverse shell can be obtained with one of the following commands used in the exec method itself. Okay, so the request over here, let me take a look. Man, it's still kind of small. So in here, this is hard to read. The response is this. Okay, so require child process .exec attacker IP in Burp. I use the repeater module in order to edit the GET request and send it in URL encoded form. Okay, so let me copy this kind of payload, and then require child process.exec netcat IP attacker. Yeah, okay. Then 0 to 22 443. Okay, so we would need to URL encode this. Actually, let's highlight this and copy it, then go back to here, and let's omit the script. So it's not script, it's just the payload. The payload here, send this. Okay, I don't think it actually interpreted that as code. Whoops. So it didn't interpret that as code. The exploit was successful. What else was it? So netcat reverse shell with the child process.exec sync commands. Okay, so let me try asking ChatGPT for some advice. So first, let's get the okay. So let's ask over here. Injecting a reverse shell payload via access is highly illegal and unethical unless you are authorized to test security in the application. Yeah, thanks for telling me that. Okay. So this is the URL of the request, which gives us XSS on the app. How would we adjust this URL to abuse Node.js in order to inject commands? Okay, let's see. Given that your current XSS payload triggers an alert, you can expand this to execute commands instead. Understanding the context, crafting the payload example. Suppose you want to execute a command via an endpoint /execute. There's no endpoint called execute. The payload might look something like this. URL encoding the payload, final URL. Okay. Command Okay, let me grab this, and let's go over to some. Hold on. I'm gonna grab this, and then I'm going to go to some URL encoding website. So URL encode. Okay. So let's start playing around with the payload in here. So this isn't going to be on execute. This is going to be in. This is going to be in the top level. So let's call this name equals -i. We're going to change the port, and then we're going to URL encode this. Okay, now it looks all funny, right? ChatGPT says script fetch execute script. Given the URL, you would replace the name parameter with the new payload. Okay, so let's go over to okay. Oh man, this is really messy looking. But let's give this a try. Okay, so did that open up a reverse shell? It did not. It did not. Okay. Let me take a look over here. Okay, fetch name bash. Let's try using netcat. Let's try using netcat instead. We should try using the netcat named pipes reverse shell command instead. Okay, so crafting the payload, final URL, right. Let me grab that, /execute command. Create a JavaScript. Okay, let's grab that. Copy that. Go over to our URL encoding site. Paste that in. Where's the decode? We want decode. Okay, decode that. We need to adjust this a little bit. 443. I don't know if this command is correct. Let me get the let me grab the proper reverse shell netcat named pipe make FIFO. Pentest monkey, where would I be without you? Okay, so netcat, this one. Let's grab that. Okay. Let's change out these variables. And then let's grab this and encode it. Okay, so this is the encoded form. Then we go back to here. We slip this between the script tags. And I don't think it worked. Nope. So this doesn't, the example in the Medium article doesn't use fetch. It uses something else. It uses require child process. Require child process exec Okay, let me grab this. And then we're going to start crafting this. Huh, I got this exact thing. We'll crowd-child process exact this thing right here, except we're not going to be using this one. We're going to use the other netcat one, which is this one. Copy that. Wait. Yeah, copy that. Then paste in here. And then go to Pebble says you can't get OS code execution with XSS. Best option is to go for cookie theft. I think because this is using Node.js, there's the possibility that we could get command injection through Node.js, because I was looking at this article there where they were talking about it. But let me give it a go over here. We're not going to stick it between script tags, but stick it over here. Okay. Not quite what we were looking for. But hey, welcome to the stream, Tebble. Thank you very much for chatting, because I know you've got your own Twitch channel, and I think I'll give you a shout out. If anybody here is looking for more shout out, if anybody's looking for more cybersecurity content, Pebble is a great resource. He streams quite often, I think. What are your hours? What time do you usually stream? Sunday. Oh, Sundays. I thought you streamed more often than that. But yeah, I usually do pretty long streams, if I remember correctly. So can't get OS code execution with XSS. Best option is to go for cookie theft. Well, if we wanted to do cookie theft, if we do cookie theft, we're stealing our own cookies. Wait, are we stealing our own cookies? How about using an XSS payload for cookie theft? You can craft a payload that sends the user's cookies to an attacker-controlled server. Okay. So first we need to script I've never done cookie theft using XSS before, so I'm not too sure. It will only be beneficial if it's sent to an admin, right? I don't know if this box is designed in this way. We can get XSS, but XSS doesn't get us very much. But I guess we could try. So by executing this payload through XSS, you could effectively capture a user's session cookies, allowing you to impersonate them or further attacks, depending on the nature of the cookies. If it's just reflected, XSS is kind of useless in this case. But something... Man, I really... This could be an indication that that we could get other code to execute because the code is not being sanitized by the web app. What's a simple payload we could send to the app to test if we could use Node.js commands on this through payloads? Laughin is raiding with a party of 2. Welcome, Laughin and raiders. Thank you for following, Laughin. Hey, what were you streaming? Laughin is now a HackerFrog. Thank you very much. Script eval. Oh, okay. This looks more promising. So we can just send this kind of payload to figure out if we can get some command execution. Laughin, yo, hello. Nice to see you. What were you streaming, Laughin? Are you another cybersecurity person as well? If you are, let us know. Let's go back to the app, and let's inject our payload. Okay, so this didn't tell us anything. So this probably means that we can't execute JavaScript. Was doing some rooms on TryHackMe. Viewers fell off a bit while I was recapping the last room, but I brought the remainder here. Thank you very much, Laughin. Yeah, I don't. Let's shout out Laughin, because Laughin is another cybersecurity streamer. There you go. Be sure to check them out. So that doesn't work. URL encoding the payload. You will need to URL encode this payload to inject it in the vulnerable application. So does that mean I do something like this? Let me... So let's try this. So Laughin, what are we up to here? Yeah, we're just we're doing some quote-unquote easy boxes from the VulNyx website over here. If you want to take a look at the VulNyx website, you can download all sorts of vulnerable machines from there and put them on your own network and then do your hacking against them. We're currently doing the Wicca challenge, which is machine number 52 on the website, but it's you haven't heard of that one. Yeah, it's not very well known. It doesn't seem to be very well known, but it's I think this is very popular in the Spanish-speaking cybersecurity community, because it seems like the organizers are Spanish speakers. The website vulnyx.com, it operates very similarly to the concept is very similar to VulnHub, but this is a much easier interface to deal with. Okay, so right, we're URL encoding over here. So this script tag is URL encoded. I don't think it went. Need to get some more water. Hold on. Laughin says, I've clicked onto some ES streamers on infostreams.com. Okay, but it's hard to keep up sometimes. Yeah, I've tried watching some Spanish streamers on there as well. Didn't work out very well. But let's try this over here. Nope. No execution here. Console output. If the payload executes successfully, you may not see the console output directly on the web page, but it can be logged in the server console or accessible through a browser's developer's tools console. Really? Wait, so if this works, I can access it through developer tools? In the console? Okay, so process is not defined. Okay, so I guess let's try the XSS. So if we just do the regular XSS, it doesn't show us anything super unusual in the console over here. Have you tried testing the token parameter? No, I haven't tried testing the token parameter. So would I put the payload in the token parameter, or? I think the token parameter has to be valid, otherwise the request doesn't go through. So if we do this gives us our XSS payload. But if we set the token to something that's not valid, oh, it still goes through. So maybe the name could be anything, and the token is the XSS payload. So name equals Bob. Oh, that didn't quite work. Okay. Would try. Wait, what happened here? Unexpected token. Okay, we've got a username. So we got a username through this, and we have a path, I guess. We've got a website path. Main.js is in /home/Alistair/website. So, okay, you know what? Something tells me that we might be able to brute force the Alistair SSH password, because I've seen patterns like this in other VulNyx challenges before. So what I'm gonna do is I'm gonna do some Hydra. Let's see, Hydra against We're going to use the good old RockU. What was it? User share wordless RockU.txt. And we're going to look for... How do you spell that name, Alistair? A-L... Wait. We're going to do SSH. SSH. Okay, let's give this a go. And let's, just for fun, let's run this with 64 threads. If this is the intended path, then it's going to let us brute force as fast as we can. But thank you very much for the suggestion to mess around with the token. Laughin says, I can't be the only one that types /user every time I'm trying to get to USR. I have to type it in backspace probably 98 out of every 100 times. Yeah, for some reason it doesn't seem to bother me too much. But I'm sure there are other people that type out the full word password when they're trying to access that funny Linux file, which is PASSWD. But let's see if we're able to brute force this Alistair password now that we have this person's username on file. Well, hopefully you didn't poison my brain. Well, hopefully my brain is less susceptible to poisoning because it's so inelastic. Let's hope that. But let's yeah, thanks Pebble. Thanks to Pebble for suggesting messing around with the token. Because we definitely got some good information through this error message here. Whether or not this is actually the way in, not completely sure. We'll probably know in a couple minutes. The great thing about the VulNyx machines is that if you have to do brute forcing, the brute forcing always uses RockU.txt, and the brute forcing always is within the first 3,000 or 5,000 lines of the RockU.txt file to keep brute forcing from being too tedious. But let's leave this alone for right now. I think I can shut down my burp suite because I was previously running burp suite. And okay. So is it really that all I needed to do was mess around with the token to get that error message? And if I messed around with the token, then it would give us the oh no! It's not just messing around with the token. It's messing around with the token and putting in an XSS payload. Let's see, Laughin says, solid, I had to use CrackStation on one of the rooms I did just because it didn't use RockU. Not many room designers will do that. Well, the room designers, wait. What was the... Oh, I changed the name to something different. Oh, is it because I put the XSS... it's because I put the XSS in the token value. Right, okay. It's because the token value had some weird code interpretation going on there. Oops, where's my... So this is still going. If I'm not able to brute force my way into SSH, then I'll be I'm not going to be super happy about that. but who knows? Let's take a look. Okay, it's because, yeah, right, I put something weird in the token value. So it's not because the token value is invalid, it's because there's something weird over here. And then it does, what is this called again? Is it called trace dump? Website, stack trace. Yeah. But this doesn't give us any versioning information on. Yeah, it doesn't necessarily give us a version of Node.js that's being used. So I guess all we need to do to trigger this was to put something unexpected into the token value. Laughin asks, have you tried the username in the what's your name form? Oh, that's good. That's a good suggestion. So what is your name? Alistair? Okay, doesn't necessarily give us anything super special. Huh. So the name of this challenge is Wicca. And I'm not sure what Wicca refers to. It might refer to something that we're doing here. It's weird that I've rabbit holed so far down this path over here on port 5000 with the Node.js, and I've basically ignored everything else on the other web server port. But the other web server port has actually, it doesn't have very much. It's just got standard default Apache 2 page. This one on 5000. Okay, so what else could we do? We could start putting our... Yeah, I've done GoBuster on both of these ports. I don't... Let me take a look at the other... Let me take a look at my GoBuster output. So GoBuster, this one was not on the 5000 port. Nope. 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 Lavin says, also let me know if you're not open to suggestions. I don't want a backseat if that's not welcome here. No, you're free to offer any suggestions you like. Because I mean, I'm not getting anywhere. I'm okay. Let's see, Hydra Restore, GoBuster. Oh, I haven't done GoBuster on this tab. Go back to GoBuster dir on, what was it? URL 10.0.2.44, wordless, user, share, wordless, dirbuster, directory 2.3, medium. With no sanitization, you could try to put a Node.js payload in the token parameter. That's true. I could certainly try that. Okay, because it doesn't look like I'm having any success brute forcing the SSH password right now. So we could do name test and token equals. So wait, token isn't going to accept these script tags, but token might accept the Node.js payloads. So I asked ChatGPT for a Node.js payload like this. It's not going to accept these symbols right here. These angle brackets it doesn't like. But we could try using these other symbols and see if it works. Okay, so let's try this payload. Let's try this. Sorry. Let's try this payload and go to the console to see if we can get some output out of this. Console over here. And console doesn't give me anything. Let's see what happens if we put an XSS payload in here. Script alert XSS. Okay, so this payload didn't work. I wonder if there's another payload we could try. Eval console log process version. URL encoding the payload. What if we use the URL encoded version instead? Okay, so I'm just going to grab this. Yeah. Okay. Put the payload in here. Okay, so it actually interpreted the URL encoding as the angle bracket. So the angle bracket broke. Caused an error in the application here. Okay, so let's see. Oh man, it's almost 8 o'clock. I need to get some dinner. Jeez. Okay, so who's online? Can anybody let me see who's online from the InfoSec streamers? InfoSecStreamers.com. Wait, what is the language PT? Is that Portuguese? Because it seems like there's another. Hold on. Yeah, okay, so it looks like this, this person... Let me grab the, So this is the channel. It looks like they're streaming in Portuguese. Well, I mean, we can give a little bit of love to this streamer over here. It seems that they do bug bounty hunting. And but thank you very much to everybody for watching and for giving useful suggestions. I need to get some dinner. So hungry. Yeah, hopefully I'm able to do some more testing against this machine a little later. But thank you very much for everybody who came by the stream. Let's do one last Hack the Planet before we go off. Very nice to meet you as well, Laughing. Hack the Planet.
Hack the planet! Hack the planet! Shut up again!
When you arrive on Jazz channel, please type the raid message hip hop hack with the OS frog, just like this. Please leave that as your raid message when you enter the channel. Thank you very much, and we will see you next time. We're going to be taking the weekend off. We'll be back on Monday, and if I see you streaming on Sunday, Pebble, I'll be sure to pop in and see what you're doing. But until then, thank you very much, have a great weekend, and we will see you next time.